In this Python course, you're going to be learning a lot of basic things to get you started in the Python programming world. So if you're wanting to learn Python programming for data science or even web development, then you are in the perfect place right here to learn Python. Hi, my name's Rob. I'm going to be the one that's going to be taking you through this Python Fundamentals course. I've taught many of courses before in person to large groups as well as small groups. And to be honest with you, going through this course, you don't need any prior knowledge in Python or programming in general to get something out of this course. It goes from the very basic levels, which is why I call it the fundamentals of Python. And so as far as the modules go, we're going to start you off by making sure that you're able to get Python to run in your Visual Studio Code. That's what we're going to be utilizing for our videos. And then of course you'll be able to go ahead and get started through the basics that the modules have set out here for you. Now, I do want to make sure that you remember that this is not a sprint. It's going to take some time. It's going to take some practice. It's going to take some repetition in order for you to fully gain on some of these concepts. Now, that's why in our modules, we're going to not only include the lesson, but they should also have some challenges for you to complete. And then we'll also provide the set of explanations that kind of go along with it. So if you're feeling stuck at any point, please feel free to reach out, as well as you can even attend to some open office hours that we offer. So good luck in the course, and let's go ahead and get you set up in your Visual Studio Code so that way you can progress throughout the modules. All right, so in order for us to get Python to run on our machines, whether we're utilizing Windows or Mac, we need to download some software that will run in the background that will help us compile our programming language into something that we can actually see and use. Because without doing this step, it's just not going to run. So the first thing that we need to do is we need to head over to this website. It's going to be in the description down below this video, and it's called python.org. And depending upon when you watch this video, you may be on a higher version number, which is totally fine. All of our tutorials will be working in the later versions. So we come up here to downloads, and you're going to notice that we have this button here. Now mine says Mac OS because I'm on a Mac. It's going to auto detect what system you're actually running, and you're going to want to go ahead and download this and install it. Now, Windows users, I'm going to throw a little screenshot that I want to make sure that you do check mark when you do install this. Otherwise, this is not going to work for you. So make sure that little check mark is checked where it actually says, hey, make sure that you want to install this on that relative path. Now, we're going to go ahead and test everything to make sure that you did install it and in the next section, once we get our Visual Studio Code up and installed as well. So we'll see you in the next video. All right, we need to get you set up with a code editor. Now, the code editor that we're going to be utilizing for this entire course is going to be called Visual Studio Code. It's a free download. Many companies utilize this software, and it's really a good idea for you to start learning, start experiencing this, so that way when you do get a job, the learning curve's a lot less when you go and actually get your very first job. All right, so let's go ahead, dive into the website that we need to go to. You'll see a link down below this video providing you with where this is at, but it's code.visualstudio.com/download at the time of this video. It can be used on Linux, Windows, as well as a Mac. And you're just going to go ahead and click on the download button respectively and go ahead and get that installed. Like I said, we're going to be adding extensions to our Visual Studio Code in another video. So once you do have that downloaded and installed, go ahead and take a look at the next video to make sure that we have all the extensions that you would need to put into your IDE. All right, so we do need to do a few extension installs for Visual Studio Code. That's going to help us as a developer, as well as learning the material, and just really to make our lives in general a lot easier. Next thing that we're going to go over this is there will be a few settings that you may need to alter, and we're going to go through those in this video. So it might be a little long compared to some of the others, and feel free to pause the video and make sure that yours is getting set up properly as well. And again, if you are needing help with this, make sure that you reach out. All right, with that being said, inside Visual Studio Code, we have this little Tetris block that we see here on the far left. That is the extensions. We can go ahead and select the extensions, and this is what I want us to go ahead and type in there. Now, I know that we talked earlier, hey, I have these cool little icons. Again, this part 1 here is optional. And if you just do a search for material icons, it's this one right here. That's the one that I'm using in case you want to make yours look like mine. The next thing that would be a must for you to download and install for an extension is the Python extension. It's made by Microsoft, so nice and safe, and then we can go ahead and install it. It may ask you to restart your extensions. Perfectly fine. Go ahead and do that. Sometimes you will have to restart Visual Studio Code depending upon what version of Visual Studio Code you have, as well as the extension setup. Next is going to be something called Code Runner. It looks like this right here, where it's a .run. That is going to help us out tremendously because we're going to be able to run the files with a simple play button rather than typing it in the terminal. And again, for Mac users, there's specific settings that you're going to want to make sure that you have set up. We're going to go over that in this video as well. And for Windows users, as well as Mac users, we're going to have some generic settings that will just make your Code Runner look a little bit better than out of the box. With that being said, the last one that will be good not only for this course, but for any follow-along courses as well, we call it Prettier. And it's usually this one right here with the blue check mark. That's the one that I use from prettier.io. It's just going to help you with the formatting of the code. And again, it works on many file types, but that's a nice one to make sure that you have stored in your toolbox. So with that being said, let's go ahead and go through some of the settings that we may need to do here for us. Now, as far as making sure that our code is running in the proper Python, because some of you may have downloaded a previous version, we want to make sure that we're rocking and utilizing 3.12, at least 3.12 or higher. Based upon this video, you can click on it down here, and this is the interpreter that you're going to be utilizing. Mac users, we definitely want to make sure that says Python 3, at least. Next is let's go ahead and set up some of our settings that we want to do here for Code Runner. And up at the top of your menu options, Windows users, it'll be under your file. For Mac users, it's under here where it's called settings. And that's what we want to open up. We're going to go ahead and type in Code Runner or just Runner to get exactly where we want to go. And this is for everybody. We want to make sure that some of these things are checkmarked that are going to definitely help us out. We want to clear out the previous output, meaning that every time we run code, we want to go ahead and basically have a clean slate and then have our code run. And this checkmark does that for us. The next thing that we want to make sure that we have set up here, let me see if I'm finding it here properly. I don't want the execution message to be shown, so this one needs to be unchecked. And it looks like I altered this one here as well, show the run command, so I don't want to see that either. And same thing for this one. So I changed all of these. All right, Mac users, you definitely want to go ahead and edit. Oh, and this one down here as well, default formatter. We want to make sure that we utilize Prettier for it. Now let's go look at the execution map. And this is for Mac users only. If we go ahead and click this edit setting in JSON. All right, this may look scary, but don't worry, it's not that scary. Let's go ahead and scroll all the way down. We want to look at for Python. This is for Mac users only. You do want to alter this right here where it says Python. Yours typically says Python on there. We want to make sure that this is updated to Python 3. That's really it. All right, let's go ahead. Once we have all this thing done, go ahead and save it, get out of there. And in the next video, we're going to show you ways to execute this hello world. And then we're going to show you that Code Runner extension. All right. So again, if you have any questions at this point, please don't hesitate to ask us because we're more than willing to help. Now that we have your Visual Studio Code opened up to the right folder, now it's time to set up our file folder structure inside of Visual Studio Code. And let's go ahead and show you how we can do that. So inside Visual Studio Code, again, I am in the PreCodeCamp folder, and this over here is our folder structure that we see. So if you click these two pieces of paper up there at the top left, you're going to notice that we do have access to these little file folder structures. That we're in the right folder. Up here, it says PreCodeCamp. And in order to add our very first folder, we click this little add folder icon. So once we click that, we're going to see a new folder pop up, and this is where we can type in the word Python. All right. So on mine, I do have this little fancy little icon, in another video, I'll show you what extensions that you might want to download. Of course, if you don't care about these icons, no worries. It's just a visual representation. And so we'll notice this little toggle icon here, and that just indicates what is inside that folder. Before, we had a video going over how to make sure that you have this little drop-down arrow from the compact folder underneath your settings to make sure that this is nice and visually accepting for you. And again, I'm going to go ahead and create a little folder here, or a little file here, and we can call this one hello world.py. All of the file extensions that we're going to be utilizing for this course is going to end with a .py, and that way it knows that this is a Python file. So that's very important. And again, notice my little icon changes to the Python logo. I get something up here in the new tab, and that is to indicate what file that you are actually adding. Now, as we go through this course here, we're going to create more folders. We're going to create other files. I'm specifically, in each one of my videos, my file folder structure will look very clean compared to yours. And that's just for the video presentation. In reality, you are going to have lots of files in here going through all of these lessons, and that's okay. That's what you want, because what we're trying to build for you is a notebook for you to be able to reference back. And in each one of these lessons here, you're going to find notes that we can put into our files that you can always search and reference to later. But that is how we can create your very first file. And in the next video, we're going to show you how we can execute some code in the Python. All right, in this video, we're finally ready to execute some lines of code. Aren't you excited? All right, I definitely am. That was a lot of setup, a lot of buildup for this, but we're going to show you 2 ways to run your code, and then we're just going to show you the code runner is going to be the one that we're going to be utilizing for a majority of the video lessons that you'll see in this course. All right, so let's go ahead, dive into our Visual Studio Code. Again, still working with the same file folder setup, and we're going to print on the terminal our very first statement, hello world, print, and then we're going to utilize left and right parentheses, and then we're going to do the hello world. Now, in Visual Studio Code, you're going to notice that we have this little white dot on there, and that means that, on my screen anyway, that it's not completely saved quite yet. And in order to have new things show up in the terminal or in your code runner, you're definitely going to want to make sure that you save it. We did add that extra saving step in our code runner where it will save the document for us. But we're going to be doing a terminal one, and we do want to make sure that it is saved. And anyways, you may not have a white dot on yours because your auto save is set up to on delay. With that being said, the quickest way to do it in the terminal, Visual Studio Code has its own very own terminal, meaning that it's built in. And we don't really have to do a whole lot of terminal navigating in order to get to the file. But typically, if you're going to be utilizing the terminal in order to execute your code, you want to navigate to the folder that is inside that carries your actual file. So if I right-click this, again, Visual Studio Code helps us out a lot. We have this little menu option here called Open Integrated Terminal. Once we have that set up, we can go ahead and click on it, and notice that a little terminal box down here is lined up. We are in our Python folder. We can type S in here, and we can see the files that are in there. And our hello-world.py file should be displayed. Windows users, you may have to type dir, but typically ls seems to work. Now, how do we execute this and see it in the terminal? Mac users will have to type out the word Python with a 3 all smashed together. Windows users, you can just type the word Python. Now, we're telling our computer, hey, I want you to utilize Python in order to execute a file. Well, it doesn't know what file name you have created or that you want to use. And we're going to hit the space bar, and let's just go ahead and start typing out the very first 3 letters of the file, which is HEL. And then in Visual Studio Code terminal here, you can hit the tab button, and that's right on the left-hand side underneath the 1 key. And we hit the tab, and notice that it auto-completed. It filled in the rest of that file for us. So you do want to fully type it out, or you can use that shorthand of hitting the tab and it should find it. Once you do that, you can hit the enter key and you should see hello world being displayed. All right, perfect. Now, like I said, if you want to make changes to this, you definitely can, and you can see it down there. Again, so I can get rid of the exclamation mark, for example, save it. Notice that my white dot is now gone. And in the terminal, I could hit the up arrow because it will allow us to go through some of the previous commands that we've used before. And we can hit the enter key and you can see that the exclamation mark is gone. It's no longer down here. So that's very tedious, a lot of work to just go ahead and do that in the terminal. Now instead, we're going to utilize CodeRunner. We should now see a play button up here. I'm going to go ahead and hit the play button, and then notice that up here on my right, and yours typically will be displayed down below. For all my videos, I make sure that they're over here to the right because sometimes I need to zoom in, and I found it more convenient to have my CodeRunner display up here. So anytime we make changes over here, because we set up our CodeRunner the way that we did, we set it up so when we hit the play button, it automatically saves the file. It doesn't show us any extra code above or below that it was running and then it ended, because we really don't need that at this point in our learning. So that is going to be the way that we are going to be showing you how to execute your code. A majority of these lessons, until we get to the input and output section, we can use CodeRunner, but whenever we're asking for a user response, we will have to resort to the terminal. Now, follow along in these next video lessons. We're going to have a different folder set up. You are going to be in the Python folder, but many times if we're teaching you a lesson, you will have a lessons folder. And then for any kind of challenges, you will have a challenges folder respectively. So just pay attention to the folder structure and you should be good to go. If you are experiencing any types of error or anything like that while trying to run this simple code that we see right here, feel free to reach out to us. We'll help you out for sure, making sure that you get started off error-free, at least for something that is very simple for us to type out and write out. We'll see you in the next video, and hopefully you're all set up. In this video, we're going to be talking about commenting inside of Python and why you might want to utilize comments. And as you're going through this course, we're going to be utilizing comments a lot. So we want to make sure that you understand how to use comments. And then when you're writing your own code, you're definitely going to want to put comments inside it while you're learning. So let's go ahead and dive right into Visual Studio Code. And I have a file folder set up here. And the setup here is going to be in our Python folder. We're going to follow that up with lessons. And then inside there, we have a brand new file called comments.py. All right. So as far as comments go, on your keyboard, you can hold the Shift button down and hit the pound sign if that's what you want to do. But there is a keyboard shortcut that you can use, and that is Control/ or Command/ in your keyboard. All right. So for example, if I wanted to do that, I'll just do a Command/. Now I get a little hashtag on there. And let's go ahead and type the word comments in here. And let's go ahead and go on to the next line. So I'm going to go ahead and make a comment on here. Again, I'm going to do the Command/. And comments are used to explain code to make it a little more readable. And it also, when we put comments in there, comments are going to be ignored by the Python interpreter. And what that means is as it sees this little pound sign or this hashtag, it's going to ignore it. It's not going to think that it's code at all. So again, comments are really good for explaining things or keeping you on track. And again, we can run this file right now and there won't be any type of error, even though we typed in human plain English in here. So those are the really good use cases for comments. Let's talk about how we might apply them and what are some examples of. We have single line comments as well as multi-line comments. However, single line comments you've already been exposed to. And let's go ahead and do a multi-line comment to show you what that might look like. And then we're going to show you some code examples, even though we don't know anything about code quite yet, but when you might want to use the comment and what good and bad kind of look like. So with that said, let's go ahead and talk about a multi-line comment. So I'm going to do the hashtag, and then we're going to go ahead and type out here a multi-line comment example. And for that, you can use the double quotes or the single quotes, whichever one that you actually prefer to use, but you need to have triple set of them. And what does that mean? Well, we can do 1, 2, 3, and notice that Visual Studio Code actually completed the remaining 3. So I'm going to hit the Enter key to give myself some space, but this is an example of a multi-line comment. Example of multi-line comment. You can type multiple lines in this comment, and they will be ignored by the Python interpreter. So again, that's an example on how you would do this with the multi-line comments. You can use double quotes or single quotes, but you need to have the same type and you need to have 3 sets of them. So that is exactly how we do the multi-line comment versus the single line comment. Let's go ahead and talk about why we use these comments and what are some good and bad examples of comments. So when it comes to comments, when do we use comments? So when do we want to use comments? Well, that's going to be for clarification. So we're going to do clarification when we need to clarify some code. We can also do it when we do some documentation of code. This can also assist in readability, and we can also use it to communicate, maybe share insights or intentions of the code. So let's go ahead and talk a little bit about, we're going to supply you with some code for this. Feel free to type it out, even though you may not know what it's for, but eventually as we go through the code, you're going to understand. So I'm going to go ahead and grab the code from below this module that you'll see this video, and I'm going to go ahead and paste it in here as a real quick example, and then I'm going to explain some stuff on it, right? So in this example here, we have a comment above some sort of section, and you can visually see that we have a length and a width. Well, why do we have a length and a width? Well, we added a comment up here that says this is going to be utilized to calculate the area of a rectangle. And then of course we can put another comment in line. You can see that this is in line, it's not on a separate line. And you'll be able to go ahead and comment on each line if you want to help along with your studies. But this is used to multiply the length and the width to get the area. So again, great example of utilizing a comment, especially going through the class. Maybe if you are in a development position, this comment might not be needed because it's a little bit self-explanatory. Let's go ahead and talk about a bad comment. And we have some examples below the video, and we're going to go ahead and explain some of these here. So the first one that we come here to is, again, I'm going to go ahead and copy this and put it in here. Feel free to type it out. But we have this comment here called, right up here, this is a bad comment. And we have this variable here, a equals 10. And then we have this very bad comment that we see right here, which is assign 10 to a. Well, if we take a look at that, why is that bad? Well, it's because that's really self-explanatory. We can visually see that. Once we get to variables, you're going to realize that a is not a good variable to pick out. But again, if we take a look at this secondary comment here, what makes this better is now we are explaining what this is about. Why is a equal 10? Well, this is the maximum allowed value for a user's input. Now that makes a little more sense, but later on in the course, we're going to figure out that this is not a great variable to choose, and maybe something else would be better. All right, that's examples of add. Let's take a look at some examples of some decent ones, right? And so again, in our module below the video, you're going to find this. So I'm going to go ahead and paste that and scroll up. So now we know that we're entering a section where the program is going to calculate the total cost of the items. Notice that we have better variable names, and it's almost self-explanatory, but again, we are able to add these nice inline comments to tell us what are these variables doing? What's the purpose of them? Well, this is the price of a single item. This is the number of items that were purchased. Let's go ahead and calculate the cost. All right, again, great comments for looking at this. And then this last one here, we want to output the total cost. And again, we're just printing it to our terminal. So those are some examples of good and bad comments. Again, as a student, I would totally recommend you put comments in your code and comment a lot. Especially, it gives you the power to go back and see what you're thinking. Once you get into the development atmosphere, into a multi-team, it's really good to have some comments in there. However, over time, sometimes comments get lost when you're working with teams, so just realize that. But as an individual user, it's definitely nice to put comments in there for you to revisit, to go back to see what you were actually thinking about back then in order for that code to work or that function. I do it all the time in my personal work, and comments can definitely help retrain or remember what you were thinking when you originally wrote the code. All right. So as a beginner, I highly recommend commenting heavily. And then as you start learning and looking at reading the code, you're going to get more aware, and maybe you won't need as many comments, but definitely starting out, make sure you put some comments in your code. And whenever you're having a review with one of the tutors or mentors, they are going to want to see comments in your code, because that's how they're going to see how your logic is going. All right. So hopefully the comments made sense. We're going to go ahead and move on to the next section. We'll see you in the next video. All right. All right. In this lesson, we're going to be talking about variables. It's going to be very important for you to know what variables are, how to create them, and how to assign values to variables inside of your programming language. Now, a variable, what is a variable? Well, I always think of it as a placeholder or something that we're storing into memory so later we can access it and later manipulate the data as necessary. Sometimes I always have students picture this. Maybe a document that you see here on your screen has placeholders for a mass email, for example. And you don't want to manually type in there the first name of that individual when you see the dear and then the first name, because that is going to be a placeholder or a variable. And we're running through a list of emails, or first names in this case here, that will be assigned that in the letter. So again, really neat way to store something into memory and then later access that data for later on. So let's go ahead and get started with variables. We're going to be taking some notes inside Visual Studio Code, so that way we can see several examples of storing and accessing these memory points. And then later on in other videos, we're going to show you exactly what are some data types that we can store in there. And so this is just going to be a general knowledge, and then we're going to do a more deeper dive into the data types. So let's go ahead and dive into the code here. So I have the file set up as the following. I have it in our Python folder, and then inside there I have the lessons folder, and then inside it I have variables.py. Now I know this is our maybe third lesson if you're going in the order here, and yours may look a little bit different based upon the file structure. I try to keep mine just clean for these video presentations. So again, yours will probably be down towards the bottom because it's in alphabetical order. Just keep all of your lessons together. I'm going to have an individual lesson per module just to keep my video display cleaner for your visual pleasure. All right. So anyways, let's go ahead and I'm going to go ahead and collapse this here. And then we're going to talk about and add some notes in here about variables. So let's go ahead and get started with it. All right, so I have a few notes here on the screen. Feel free to go ahead and type them out as we're going through this. But variables, right? Why do we need variables? Now we need variables because one of the first reasons that I'm going to put on here is for data storage. That's where we see this number one here, data storage. And this allows us to store data inside the program for us to use and reference later. And a great example of this, and let me go ahead and put these notes on here as well. For data storage, variables are used to store data. And for example, we can store a variable as opposed to writing them out. So I'm going to keep that on the screen. So an example here that we're going to do is let's do one without variables. And then we're going to include variables to show you the difference between them and how much more readable it will be when we use variables. So if I just do something like this, and I'm going to put our hashtag in here, and we're going to call this one without variables. we must use the raw values, right? And what do I mean by this? I'm going to do print, and I'm going to do, for example, 3.14 times 2. And so that's just going to simulate pi r squared, right? And our radius is 2. So if I were to go ahead and save that and run it, obviously we get the 12.56 over here. But what I really want to showcase to you is, what if we were to store this in variables, right? And this is how we're going to write out variables. And we're going to talk a little bit later on in this discussion, what are some good ways to make variable names? So whenever we're trying to create a variable inside of Python, we want to first name the variable, then we want to provide an equal sign, and then we want to provide a value on the right-hand side. And so with that being said, let's take a look at how we could rewrite this to make it a little more readable and store information inside the variable. So let's first just do radius, and we're going to set that equal to. Now, if I ever need to find out, hey, what is a certain value given here that we stored in a variable, I can simply print the radius. We can reference that inside the code. So let me go ahead and save that real quick. And then I'm going to clear this out by typing clear. And then now I can go ahead and hit the play button. And again, I get this right here too, which is what I would expect because I'm printing the radius here. Let's go ahead and add a few more variables to this. We want this to have pi. We're going to set that equal to 3.14. And then we're going to do a calculation. All right. And we're going to say area equals pi times the radius. And that's the same thing as pi r squared times radius. So down here, instead of printing the radius, I'm going to do this real quick. And then I'm going to do, just so we can see this inside of our terminal area. So I'm going to go ahead and save that, clear it out, and then I'm going to run this. So there it is right here. That's what we're looking for. Area is 2.56. And again, we're getting it from the variables that we created. Again, play around with this. What if you were to do 5? You can change the radius to 5, save it, and then we can run it again. And this time we get 78.5. Okay. So we just showed you that, hey, having a variable and storing it, and then here we're referencing it, and down here we're printing it. So we're combining a lot of things that you have been learning in previous videos. All right, let's take a look at the second reason why we need to have variables. So code reusability. This enables us to write code that will work in different places inside of your script. And an example of this is, for example, we wanted to do circumference, but let's put some notes on here first. We're going to make this code reusability variables that can store data reused again over and over throughout your code environment. And something that we're going to do is we're going to do circumference. And if you remember from math, circumference is pi times diameter. And let's see if we can do the following. And this is what I would like you to do. Go ahead and pause the video once I give you this prompt here. So we're going to do the circumference of a circle, and that happens to be pi times diameter. Now, what I would like you to do is pause the video and see if you can go ahead and create a variable assignment for the diameter. And let's go ahead and set the diameter to 25. All right. So go ahead and pause the video. Don't go into the calculations quite yet. We're going to talk about that, but just see if you can create that. All right. Well, hopefully you ended up creating that. And what we're going to do here is we're going to go ahead and come over here, and we're going to do the following. We're going to say diameter is going to be 25. All right. Now, how are we going to print the circumference? Okay. Well, circumference is going to be pi times diameter. Now, the question that you have to ask yourself here is, why do I not have to put another pi down here with 3.14? Well, that's because we're already using it up here. It's already been defined from our previous example. So we don't have to redefine and assign it. It's going to stay the same, 3.14. So that way we can go ahead and use it again. If I'm going to print this out, we're going to do circumference. comma circumference. I'm going to go ahead and save this. And if I went ahead and ran this, notice that I do get the circumference of 78.5. So I didn't plan on this being the exact same number as the area up here, but let's just double check this. We'll do 30. We're going to save it, and then we're going to run it. And there we go. We got the circumference 94.2. So that is our reason number 2 that we have the variables. The next reason that we have is going to be code readability. And let's go ahead and learn a little bit more about it. So code readability, this is where variables are very descriptive in their names. It makes the code easier to read, not only for you as the original author, but for anybody that might be on your team that will take a look at your code, right? So whenever we're coming up with variable names, we want to make sure that they're clear, concise, they have purpose. We're going to be talking about creating variable names, some good naming conventions a little bit later on in this video. But for now, just to give you an idea with the code readability, let me go ahead and put these notes up here for you, that when it comes to multiple words in your variable names, because that can be descriptive, right? We want to add an underscore to them. For example, if I wanted to create a variable called number of apples, right? If I come over here and I do number of apples. Now, this is going to give us an error if we try to run this in Python. And it's because whenever we're coming up with variable names, there's going to be a little bit of rules associated with it. But before we get to that, in order to make multiple words variables, we're going to have to put an underscore in between each one of these to connect them in a snake case type of format. And that's exactly what it's called. Hopefully you picked up on some of these things that we've been doing so far. Variable names, they're typically lowercase, and they're going to have an underscore on them if they're going to contain multiple words in them for readability. So number of apples, we're going to set that to 10. And then we're going to do number of oranges, and we're going to set that to 5. What I would like you to do now, pause the video, go ahead and create a variable called total fruits. And then I want you to assign that to the number of apples plus the number of oranges. And then we're going to print that in our console. So go ahead and pause the video right now and create that new variable called total fruits. All right, well, hopefully that ended up working out well for you. Do something like this. We'll say total fruits equals the number of apples plus the number of oranges. So we're going to go ahead and save that. And then we need to print the total so we can see it in the console. So I'm going to go ahead and save that and run it. And we can see total fruits here is now 15. Perfect. That's exactly what we should see. All right. So variable naming conventions, we want to make sure with good variable names. I have a set of 4 rules that we can follow through with when it comes to naming your variables. And I'm going to tell you, it's one of the most difficult things that you might think is really easy to do, but sometimes it's hard because you're trying to make sure that the variable that you create is going to be descriptive enough and be useful enough for not only you when you come back and visit your code, but for others that might be on your team. So you're definitely going to want to take some of these rules that we're going to come up with here and use them in your everyday coding. So the first thing that we want to do is we want to make sure that we come up with descriptive names. All right. And once I show you the descriptive names on these 2 variables here, you're probably going to see, without me putting comments on there, which one's good, which one's bad. But we want to make sure that we're giving useful and meaningful names that will describe the purpose of the variable. So with that here, I'm going to go ahead an extra space here, but we want descriptive names. I have this right here. It says total cost with an underscore, right? Underscore equals 100. That's good. Now we have this TC here. Really don't know what that is. Maybe if you created it, you know it, but another developer that comes in here has no clue what TC means. So again, you're not getting charged any extra money for utilizing descriptive variable names. It doesn't cost you anything. So go ahead and utilize it. Again, you see that we're utilizing some of the stuff that you've already learned, which is we need to make sure that it's snake cased. So to a computer, TC is fine, but to a human, it's not fine. All right. It should be able to be read and understood what you're trying to get across. The next thing that we're going to talk about is in Python, we want to lowercase our letters So there's not going to be an uppercase and lowercase, no camel case, no Pascal casing. It's going to be snake cased. So we want the lowercase letters to be utilized with underscores. Number of students. That is perfect, right? Number underscore of underscore students equals 30. That's good. Bad would be the naming convention that we just saw down on line 47, which happens to be Pascal casing, where the first letter is capitalized and then every other word is capitalized as well. So we want to make sure that it's lowercase. Now we also want to make sure that we avoid reserved words. And what do I mean by that? So far we've learned about the print statement, right? Well, guess what? You can't use print as a variable name, even though it might be a good one for you to think of, right? But you're going to have to avoid that word. So Python has reserved words that cannot be used as variable names. For example, the print statement. If I said print equals 10, I'm definitely going to get an error. So just things to keep in mind. As we're going through this course, you're going to learn what other key things are protected that we can't use. But the print statement is one that we've already visited. So I'll go ahead and put something in there that you already know. Now, the next thing is case sensitivity. Python is case sensitive. And what does that mean? If I come over here, give myself some room, and I'm going to go ahead and scroll up just a little bit. So Python is case sensitive. That means that the uppercase and lowercase letters are treated differently, meaning that if I have something on my line 57 equals 100, as a human, I see line 58. I'm thinking to myself, well, total cost, that's the same, right? It shouldn't matter whether it's uppercase or lowercase. There shouldn't be a difference. But if I were to go ahead and run this, I'm definitely seeing total cost being 100. And that's because it's referencing the total cost, and the T and the C are lowercase, which references my line 57. So that's what I'm trying to get at when we're talking about case sensitivity. Case does matter. And that's something that is going to be a little bit hard for new students to learn and grasp, but just know that syntax does matter, case does matter when it comes to it. All right. So with that being said, there's a lot of things going on here in this lesson with variables. You're going to be utilizing it every single time that you program and reference. Variables are going to be all over. In the next couple sets of videos, we're going to be talking about the data types, what kind of data types can go into variables. But feel free to scroll down below this video. There's going to be some more examples of what I was talking about that you can just read over. And we'll see you in the next video. Till then. All right, in this lesson, we're going to be talking about strings. We're going to introduce to you how do you create strings. You may have figured some things out so far with all of our videos that we've been doing so far, but we wanted to show you there's multiple ways to create strings within Python. What are some good practices as well? So let's go ahead and dive into the code here. So what I have set up is inside Visual Studio Code, I have our Python. I have inside lessons folder. We have the strings.py, and that is going to be our starting point. All right. So I'm just going to go ahead and collapse this to save us some space. So strings, right? Strings are a sequence of characters. Strings are used to represent text and contain letters, numbers, symbols, as well as white space, meaning anytime you hit the space bar. Now, it also says on here, strings can be created utilizing single quotes, double quotes, or even triple quotes. And we're going to demonstrate all of those here to you. So let's go ahead and start showing you some of the differences. All right. So if we're going to be utilizing single quotes, it's going to look just like this. They're just the quote marks key right next to the enter key is what you're going to be utilizing for it. And it will work the same. So if I were to print this out for the single quoted string, save it and run it, we do see the hello world. All right. So again, your choice on whether or not you want to use single quotes. Let's go ahead and demonstrate that we can do that exact same thing with double quotes here. And we'll go ahead and print it also. So let's go ahead and save that, run it. And we have this Python is fun being displayed. So the double quotes work as well. Now, something to note on this is if you use a single quote over here, you're going to have to match it up with the single quote there. Likewise, if you have a double quote, you're going to have a double quote on the other side. All right. Now, the last one here is triple quotes. Why would you want to utilize triple quotes? Well, that's just in case you may have multiple lines. So let me show you what that would look like here. And I'm going to go ahead and put this in here. We'll say something like multi-line, and we'll say this is an example of a multi-line string. Notice that I can go ahead and hit the enter key and it will go to the next line. And then I have to end it with the triple quotes. All right, that's going to be very important when we're doing this one. And so I'm going to go ahead and save that and run this. Once I add a print statement, I'll go ahead and run it and save it, run it. And there we go. We do have it being multiple lines. And to better demonstrate that, I'll go ahead and hit the enter key one more time to just show you that this does work. I'm going to go ahead and run it, and you can now see that they are separated here by one line. All right. So that's the double quote, single quote, triple quote on how you can utilize that with strings. I will say that typically what you'll find is that the double quotes are going to be what you'll be utilizing, and you'll only utilize the triple quotes if you're trying to need multiple lines when you are developing. All right. So let's go ahead and move on to how do we access an individual character inside of a string. All right. That's what we're going to talk about next here. So when it comes to accessing a character inside of a string, strings are actually indexed, and that way you're able to access individual characters based off of their position. And with any typical coding language, Python, JavaScript, for example, everything is indexed and it starts at 0. So let's go ahead and create just a real simple text here. We'll do something like this. Let me go ahead and scroll up just a little bit so it goes up in the view. We'll do text equals, and we'll just do Python. Now, like I said, each letter we're able to access individually. You're going to have to think about this as if we're splitting this up letter by letter, which letter are we wanting? What we're going to have to think about in our minds with programming is everything starts at 0. So when we count, normally as a human, we'd say that this is the first letter. Well, in programming, this is the 0 position, and so on, right? 0, and then the Y would be the 1, for example. So how do we access that? So let's do something like this. We'll say first character equals, and then we're going to call out the variable name that we see right here, which is text. That's what it's referencing. And then we want to grab a hold of the 0 position of the text. And so for this, we'll just go ahead and print first character, and then we'll call out our variable of first character. So let me go ahead and save that and run it. And notice that the first character here is the letter P. It's all capitalized, right? Now, let's go ahead and see what can we do to grab the last character. Well, let's go ahead and create that. We'll do last character. And in the box here, we'll go 1. We'll start off with 0 here. We'll do 0, 1, 2, 3, 4, 5. So if I want to grab that last character in there, I can put a 5 in there. I'll go ahead and hit the save button, and we'll go ahead and print it, save it, run it, and now we have that last character of N. So notice I had a 5 in there. Now we can also count backwards, right, from the end, and that's what it was originally trying to suggest in here is we can put a -1 in there and get the exact same thing. So I'm going to go ahead and save it and run it. Notice I still get the N. Why would we want to use a -1 instead of the 5? Well, what happens if we put Python rules in here and we did put the last character in here as 5? We would no longer get our desired letter, which is the S. So if I run this, notice I still get the N, but if I came over here and added the -1, we now have a match for the last letter. So we just made a really dynamic way of grabbing that last letter. And we're going to be giving you challenges later on throughout the course that may test you on this knowledge of making sure that you're able to grab the last letter, for example. All right, so we're able to grab the first, we're able to grab the last. Now, what if you would like to have maybe accessing the subheadings, right? And that's where we can have a start and end. So let's go ahead and make this another point here, accessing subheadings or substrings, I guess. And the way that we're going to do this is we're going to take whatever our variable name is, and then inside of the brackets here, right, we can put a start point and an end point. And that's how we're going to determine it. So let's go ahead and do another assignment of the text. We'll do text equals, and we'll do Python programming. And say we wanted to grab the Python aspect of this. So what we're going to do in this, we'll call this one substring. We're going to set that equal to text, and we want to grab the Python out of it. So we want to start at the 0 position, and we want to go all the way down and stop at the 6th position. So that's what that's going to give us. So if I did a print here of substring, save it, run it. Now we did in fact get the Python aspect of it. So I'd recommend you playing around with this and see if you can grab the programming aspect out of it. So feel free to pause the video and give that a try. All right, so hopefully you ended up getting it. If we go ahead and save this, run it, we get the 7 and the 18. And just find that we went all the way to the 6 before. That was our ending point. And then that means we picked it right back up at the 7. And then we go all the way down to the end. Now, one of the things that we know since we wrote this part here is that we would like to start at the 7 and go all the way to the end. You can definitely omit the second number after the colon, and it will go all the way to the end, right? So if I were to hit the play button, again, I get no changing on this. And if I did is fun, we no longer get the programming aspect, we get is fun as well. If I were to save this and then run this, you can see that we got programming is fun. So another side note on this is if you omit a number at the end, it will assume that you want to go all the way to the end of that string. So to get that back, I can just send it back to 18 and run it, and we get programming. So hopefully this is starting to sink in with you all. And the next topic that we're going to talk about here is string operations. There are going to be a few string operations that you're going to want to commit to memory to know how to do. So that way that when you are proposed a problem of that nature, you know how to search it and find it and use it. So string operations. So Python provides us with several operations that can perform on a string to include concatenation, to include repeating, and to even calculate the length of the string. So let's talk about string operations. So string operations. Now, if we are wanting to concatenate here, and I have it down here below in our video, if you want to copy it, feel free to. I'll go ahead and explain what's going on. But we have a first name of John. We have a last name of Doe. And we would like to combine that and store it in a variable here called full name. So what we would do is we would type out full plus, and then we have to put a hard-coded space in there in order for it to deliver it as we would read it as a human, right? First name plus, we're going to add a space, and then we have the last name. And then obviously we can print the full name. So let's go ahead and save that, run it, and we get John Doe. All right. Again, if I were to omit this, let me go ahead and delete it. It's just going to concatenate them and smash them together. So let's see what that looks like. You can see that right there, John Doe, right? I'm going to go back to the proper way of concatenating there. Now, if you ever find yourself in the need of repeating something, so we'll put in here repetition. And our example that we're going to use is we're going to repeat the greeting of hello, and we want to do that 3 times. So the way that we're going to do this is we create a variable here called greeting, and then we're going to create another variable here called repeated greeting, and we're just multiplying our hello by 3, and then we're just printing it to the console here. So as you can see, it's going to go hello, and let's see what we get here. Let's go ahead and save it and run it. and we get hello, they're all smashed together. All right. Now, the last thing that we'll talk about here is we've learned now how to concatenate them, push them together. We've learned how to have something repeat. And then the other common one that we're going to use a lot in this course is, of course, how do we determine the string length or the string size, right? How many characters are in there? And so in order to calculate the length of a string, we're going to utilize a function that's built into Python, and it's called the length function, but it's shortened to len. As you can see on my line 53, we have the len of text. So let's walk through this line by line. If we look at line 52, we're setting text equal to Python. And then the length here, we're utilizing that function, and we're supplying it our variable, which contains the word Python. And then we print the length of it. It's going to print out 6 because that's how many characters it has in it. Now, this is one of the cases where it actually starts off with 1, right? And so if we're saying, we're counting the length here of it, this is 1, 2, 3, 4, 5, and 6, right? So this is one of the instances where the program actually starts off with 1 and finishes the count. Now, the thing that you also have to keep in mind is that if we were to put Python is fun, and we're counting this out, right? I'm going to go ahead and run it. We get 13. If Python was 6, and then the 7, 8, the fun is 9, 10, 11, where did the 13 come from? Well, it's including spaces in there as well. And notice that we have a space between the Python and a space between the is and the fun, right? So spaces do count when it comes down to the length. So that's something that you want to keep track of and understand, right? So that kind of sums us up for strings, and you're going to take this and use it all the time. So please try to commit those things to memory. So that way it just makes your life throughout this course here a little easier to know how to create a string and how to concatenate them. We're going to go over other string types of methods out there that might be a little bit easier to use if we're thinking about concatenating them. So please watch the next few videos that we're going to go over it. In this video, we're going to show you how we can utilize formatted strings inside of Python. It's just a different way for us to concatenate them or give that illusion of concatenating when we're really simply just injecting the variables inside of the string. And you're going to see this and you're going to utilize it. I think it's a real slick way of going about inserting variables inside of a string. So let's go ahead and take a look inside Visual Studio Code. This is what I have set up here for us, which is the Python folder, right? We have lessons, and then we have formatted strings as the file. Now, just like I told you before, I'm free to go ahead and type this out while I'm talking about it, but formatted strings allows us to insert variables inside the string. And this is going to be done utilizing curly braces, and method's going to take the variables as the arguments, which is kind of neat. So let's go ahead and see. There's two ways to go about this. So the first way here is we're going to create a variable here. We're just going to call it name, and we're going to set it to Alice. So we'll do name equals Alice. And then the next thing that we're going to do is we want to set the age. We're going to set that to 25. All right. Now, as far as this next part here, I'm going to go ahead and put in some notes here. So we're going to replace the curly braces. So whenever we're going to create this, you're going to see that we're going to create some curly braces as placeholders. And then at the end, we're going to apply what we want to go inside of those curly braces. So let's go ahead and write a print statement here. And we're going to type this out here, and it's my name is, and then it's going to be empty curly braces. So we're not going to put anything inside there. It's just going to be empty. And I am, and then curly braces, years old. And notice that we're putting spaces in between this. And again, these are going to be like, right? And at the very end of this, we're going to utilize the format method. And inside the format, it's going to take two arguments, two parameters, two arguments. and it's what we want to put in there. Well, the first one, my name is, well, you guessed it, we need to put the name variable in there. And then the second one here is the age. So in order, way that it finds the curly braces as opposed to the variables that you have here. So let's go ahead and save this and run it. And you can see my name is Alice and I am 25 years old. Feel free to pause the video, play around with this, swap the two, and you'll see my name is 25 and I am Alice years old. So it goes in order. Now, I tell you, this might not be the easiest one to use, especially once you start having more and more variables to make this more of a dynamic string, right? It's going to confuse you with the placement. Now, my preferred method here is we can actually prefix the string quotes, slice the curly braces, and inside the curly braces, we can actually apply variable itself, and it makes it so much more readable. Now, what's the difference here? Well, notice that we have here this F, right? We are saying, hey, we want to format this string, and anytime you have a curly brace, I would like to supply the variable that I want to have go in. The case here, on my line 17, name gets replaced with Bob. So if I were to play this, I would get Bob, and I'm 30 years old because the age has been updated for this scenario. So anyways, hopefully that kind of clears things up when we're talking about creating dynamic strings, a way for you to format your strings in a cleaner, more readable code. And I just want to provide those two different ways of doing it. Again, no right or wrong way. I will tell you that things are going to get messy once you probably have more than 3 of this utilizing the dot format method. All right. So we'll see you in the next video. All right, in this video, we're going to be talking about string methods and when you might want to use them in your programming. Now, we're also going to provide you with challenges that are going to reinforce these ideas, these concepts, but I'm going to break this down and tell you when you might want to use each one of these methods. So let's go ahead and dive into the code here, and then we'll get you all started with some of startup code. So inside Visual Studio Code, we're going to be in the Python folder, lessons, and then inside lessons, we have string-methods.py. Now you're going to see all of this code that we have right here. Don't worry, I'm not going to make you type it all out. Underneath this video, you're going to see starter code, and you can go ahead and copy and paste it into your file. And that way it kind of helps with the saving of the time. This part here is not too hard with some of the things that it does. All right, I'm going to go ahead and collapse this, give me more screen real estate. Now, a string method, basically it's a built-in function that's inside of Python, and it allows us to perform different types of operations on a string where we can manipulate it. We can give it an analysis. These methods provide us powerful ways to convert text, convert the string. Also, we are able to search for patterns, and we can even replace parts of a string utilizing some of these built-in methods. Again, we didn't have to write any single code to get some of the benefits of this, and they're built into Python for us to use. So let's go ahead and dive into the very first one here, which is the upper method. So the upper method works where it's going to take our variable text and convert it all to uppercase, just like it says. Now, any one of these methods that we are going to be talking about for the first couple ones, they return something, right? They return a value. And that way, we're not actually manipulating the original variable. And let me demonstrate that here. So let's first create a variable to store stuff in. So let's go ahead and call this one upper text. And we're going to set that equal to text.upper. And we need to invoke the function, which is why we have these left and right parentheses that you see right here. Now, if we were just to save this and run it, it's not going to work because we need to actually print something. So we can do the print statement, and we're going to print the upper text. And what we're expecting to get as a result here is the Python programming all in uppercase. Now, to demonstrate that it did not affect the original variable of text, we can come down here and do a print of text, and you're going to notice that, hey, it didn't manipulate it. So we have now the lowercase, or the normal case that we had up there on line 5. All right. So that is the uppercase. Next thing that we'll talk about here is the lowercase, and it's going to be kind of the exact same thing. And again, with programming, you're going to start seeing patterns, and you're going to be able to recognize, oh, if that worked for the upper, then maybe if I just do a dot lower, it's going to work, right? And that's exactly going to be the case. So we're going to do lower text, and then we're going to go ahead and print it out. And then we're going to go ahead and save that and run it. And notice that we now get the lowercase version of it. Now, one of the questions that you might be asking yourself is, why would I ever want to do something like this? Well, there might be a time where maybe you're doing some sort of comparison. I know we haven't talked about comparisons yet, but just like with variable naming, right? If we had an uppercase text, we're not going to be able to print anything. We're not going to be able to see anything, meaning that if I were to do something like this, if I were to do print text, we're going to get an error. Notice that this part here is all uppercase. Even if I were to do something like this, we're not going to be able to print anything. We're going to get an error because this does not equal this. And so a way to think about this is, what if I were to do a print statement and I said, you know what, let's go ahead and let's do a comparison real quick. I know we haven't talked about comparison, but let's see if text is equal to the lower text. And of course, we're going to get a Boolean value, and I'm going to go ahead and hit play, and we're going to get false. And even though Python programming, if we look over here, Python programming to us as humans is the exact same thing as this in P's match, but because we have an uppercase P and a lowercase one down here, the comparison fails. So again, I know we haven't talked about comparison yet, but I'm just trying to put that little thought, that little idea in your head that this is a possible use case, for example, on a form where we're checking something, right? Or maybe you want to put something into a database and somebody typed in an email and you need to make that email a little better with the formatting when it goes into the database. So that way, when we're checking for an email, we're looking for a match with it all based off of lowercase letters that were stored in the database and comparing it to what the user typed in. So just putting a little future motion thinking in your head at this point, but that would be why. Next here we have capitalize. This will capitalize the first character to uppercase. So let's go ahead and try this one out. So we'll do capitalize text, and then we'll do the dot capitalize. And then of course we're going to print it. And notice here that we get the Python programming, okay? With the capital P, it kept the capital P. Even if it was lowercase, it would have capitalized it, and then it finished the remaining part of it to be all lowercase. All right, let's go to the title case. And for this, we're going to add a new text here. We'll do text equals Python programming, all lowercase. And then if we do the title case here, let's go ahead and save that and run it. After we print it, of course, we will get the proper way of it being like a title, right? Where we're putting a title on an HTML page, right? An H2, an H1, right? So we're just title casing the text. The next one here, we're going to talk about the find. And for this, I'm going to have an example. We're going to give it a sentence here. And we're going to say the following. We're going to say, the quick brown fox jumps over the lazy dog. And then what we want to do here is we are now getting a brand new variable, which is index, and we are assigning it whatever the method returns of the word fox. So it's going to find where it encounters the very first instance of the word fox. So to demonstrate that here, let's go ahead and save that and run it, and we get 16. So it is 16 characters away, 16 spaces, right, away is where the index is going to be. And remember, it's 0 based. Now, if I were to put the word fox over here and run this, we get 4. Again, it's only returning the very first instance that it finds it, and then it exits out. It's no longer going to tell you the next time it finds it. So potential use cases for this would be, maybe you're trying to find to see if you're matching some sort of serial number, a zip code, those types of things. The first 5 of the zip code, for example, right? Or Maybe you're trying to match a pattern to see if the serial number matches. So those are types of things to look at when we're trying to utilize the find. Now, when it comes down to the replace, we can have something here like text, I like apples. And we can come down here with the new text and let's replace the apples with bananas. So the way that this one works is it's going to look through this entire string and it's going to try to match up the apples. And once it comes to apples, then we'll go ahead and throw in the bananas. Of course, let's go ahead and look at the new text here, and then we can run it. It says, I like bananas. Let's also check the text, and we'll show you that it does not destroy the original text. So that's something very important to know. And then the last one here that we have, the last two examples that we have, going to talk about the in operator. Now the in operator checks to see if the substring exists, and it returns a Boolean value. I know we haven't talked about Booleans yet, but Boolean can mean true or false, meaning did it find it or did it not? One of the things that we can do here is, let's look at this. We'll do text equals the quick brown fox, and then we'll come down here and we'll say is present. We're going to set that equal to fox in text, meaning did it find this word in the variable of text? Okay, and then we can go ahead and print is present, and then we can go ahead and save that, and then we get true. Maybe a potential use case in this is if you're utilizing some sort of filter on what somebody types in. Maybe it's a bad word that you don't want to have inside of somebody saving into the database, right? Maybe a social security number you don't want to have in your database. You can search for patterns, right? If it is present. So there's the in, and then of course we have the not operator, and let's go ahead and do an example of the not. So we'll do the not in, and the example of utilizing the not in, go ahead and remove that, is the quick brown fox, and then is absent dog not in text, right? So it's taking a look and saying, hey, is the word dog not in the text? If that's true, if it can't find it, then it's going to report true. So let's go ahead and run that, save that, and we get true. So I know that we went over a lot of this. There's going to be some sample of check on learnings down below, and also take a look at the challenge that's going to be associated with this in the next module. So we'll see you then. In this video, we're going to be learning about strings with escape sequences and when and why we might want to utilize this, especially since we're on the topic of strings. Let's first talk about our file folder setup here. So inside Visual Studio Code, I have it set up as the following. I'm inside the Python folder under lessons, and then I have our file here called string-escape-sequences.py. Then I also have some notes here for us, but I'll go ahead and talk while you are all typing this out. So escape sequences is for solving the problem, because if we know that we have a variable and it's inside of double quotes, well, what if we want to put another set of double quotes in there? Well, we're going to need to have some sort of way to break that up. And let me first show you the problem, and then we're going to go ahead and solve it utilizing an escape sequence. So with that being said, let's just go ahead and do course equals Python for beginners. And if I were to go ahead and print this out, of course, we're not going to get any kind of error. But what if I wanted to have the beginner right here, if I wanted to add another quote here? Notice that Visual Studio Code is automatically throwing up a red flag, an error, and it's not going to let me compile this and run this. And the reason behind it is, if we take a look here, we have our first double quote, and Python language, the interpreter is thinking that, hey, this is the ending of it. It doesn't think that you want to include it in the actual string. Now, of course, we can solve this problem by changing our beginning and ending quotes to be single quotes. So let's go ahead and try that just to demonstrate that it does work. So I'm going to go ahead and change that to a single quote, as well as this one to a single quote. And if I save it and then run this, I do get the quote that you see right here. It's in there, it doesn't break. But we as programmers, I told you in the last video that the double quotes will probably be the preferred one that you would like to use. And maybe you don't want to change up your coding style just for a one-off. How can we still keep the double quote standard that we set forth when we first started coding? Well, the way to do that is utilizing an escape sequence. And if we're utilizing double quotes here, and again, this only applies if we're utilizing the double quotes at the beginning and the end, is we need to put in that backslash that we see right here. Notice that it no longer is showing red except for that character. If I were to go ahead and save this and run this, I get no difference than what I had with single quotes. So this is the escape sequence right here. That's our escape character. And then the two combined make it the sequence. Let's take a look at what about if you wanted to do the single quote, right? Well, if your standard was having single quotes on here instead, you would have to do your escape sequence with a backslash and then the single quote. So if I were to go ahead and save that and run it, notice that we now have the single quote over here instead of the double, and everything is happy. Now, as far as new lines, this is the escape sequence for it. There's going to be times in this programming course that you're taking where you're going to want to have a multiple line thing, and without using the triple quotes like we learned before, you can definitely do a \n, and that stands for new line. And we can go ahead and save that and run it, and notice that the beginners has now been shoved down to the bottom, and that is giving us a new line break, right? That is escape sequences for you utilizing Python. Of that to memory as well, or just know that we've talked about it in the past, and feel free to reference this video or your notes to know how to make a new line, how to not have your code break if you're utilizing double quotes and you needed to have another quotation inside there. I just want to take a real brief moment here of your time and say thank you for watching this, first of all. And if this is something that you are looking to do, advance your career, move a little bit quicker through this, then we definitely have a plan in place for you. Take a look at the description below the video. There's going to be a very special link just for our YouTube viewers that are watching this video. And it is not only going to have recorded lessons, you're going to get live help, as well as live graded feedback on all of the things. And it's for a very fraction of any kind of cost. So just want to take that brief moment, take a look at that link, see if it's for you. If not, hey, keep watching this video. We're still going to be giving those tutorials. All right. In this lesson, we're going to be talking about numbers. All right. So we've already learned about strings. Now we're moving on to numbers. And when we're talking about numbers, there's three types of numbers that Python allows us to use. There's going to be an integer, there's going to be floating point numbers, and then you have complex numbers. And really, we're only going to focus on the integers and the floating point numbers in this lesson here. Complex numbers are going to be more or less the imaginary numbers, if you remember that back in algebra. But we're going to focus on the integers and the fixed point numbers. So let's go ahead and dive into Visual Studio Code here. And what we're going to see here as far as our setup, we're in Python underneath lessons, and inside there we're under numbers.py, right? So here are some notes. Again, we're dealing with numbers. I told you that there's three types. What are the differences in the integers versus floating points? Well, integers are going to be dealing with whole numbers, and this can be positive or negative. If you think about a whole number, we're talking about there's no decimal points, there's no fractions. It's just going to chop it right off, and we're not going to have any kind of decimals. Floating point numbers, that is going to be with decimals. So this can be with decimals, and we're also going to deal with fractions as well with this. Complex numbers, again, that's going to be numbers with real and imaginary parts. So real and imaginary parts that would be involved with this one. So understanding how these types allow you to perform different mathematical operations will definitely help you out here. So let's take a look first at integers. So when it comes down to the integers, we are talking again about no decimal points, and this can be positive or negative. So for example, we'll have a positive integer, we'll have that set to 10. We'll do a negative integer, and that's how we can represent a negative number which is just a minus sign in front of the number. So again, integers, they're precise. There's absolutely no accuracy when representing whole numbers, but they can also represent large numbers as well. And we are only limited by the machine's memory whenever we're utilizing these. Let's go ahead and talk about floats. So inside of floats are numbers with decimal points, allowing representation as far as fractionals. They can also be used for more precise calculations when it comes to the math, whenever we're trying to divide, right? So let's go ahead and show a few examples of what it looks like. So we'll do a positive float. We're going to set that equal to 10.4. Do a negative integer, and we'll do a negative 10.4. So again, these are going to be integers. Now, like I said, we're not going to talk about how we can make complex numbers. We just want to start off with the basics and the foundations with this. So if you are looking for complex numbers, we'll provide you with documentation and a little bit of examples below this video if you want to extend your reading when it comes to the complex numbers. Now, whenever we're talking about numbers, we can start doing math with it, right? And I think we've seen a couple instances so far with some of the early videos that you've watched with how you can do some arithmetic operations. And so with that being said, let's go ahead and do the following. Again, we're not looking for, are these variables nice and concise? We're just looking for main concepts with this. So we'll have an example here of A equals 10 and B equals 3. And so that way we can see what is going on when we're trying to do some math functions. So we'll do addition. So if we're ever adding variables together that are numbers, we can represent that here. If we're looking at subtraction, all we have to do is put the minus sign in there. All right. Multiplication, we're not going to use an X in order to represent it, but we're going to utilize the star key. If we're looking for division, that's going to be the forward slash. It's not a backslash, it's just a forward slash. And that will divide the two numbers. And then as far as another one that we're going to utilize a lot is the modulus. So if we do a modulus, that's going to be the percent sign. And this might be something very new to you as far as what does the modulus mean. That just returns the remainder of the division. So if there's any type of remainder that comes out of this, so if we're doing 10 divided by 3, 3 goes in there 3 times with a remainder of 1. And so we can get a remainder. And later on in some challenges, this is the one that you're going to want to remember, all right? Because we're going to help you determine if a number is even or odd by checking out the remainder. Is the remainder 0? That means it can be evenly divided by that number, right? So a little note on here, this is the one that you're going to want to use and think about when we're talking about evens and odds. Then if we're ever looking to do exponential type of math, so we can do the exponential, and that's utilizing 2 asterisks on there. And that means this is going to be 10 to the 3rd power. That's what the double asterisks mean. All right, and we can go ahead, if we want, we can print each one of these. So we can print the addition, we'll do the subtraction, multiplication, division, print the modulus, as well as the exponent. All right, let's go ahead and save that and run it. And we can now see that 10 plus 3 is 13, 10 minus 3 is 7, 10 times 3 is 30. And then notice that we do get this floating point here, 3 for the division. And then we also get for the modulus, it's the remainder of 1. And then the exponent 10 to the 3rd power, you get 1,000. All right. So various arithmetic operations that you can see that are performed there. All right. Next, we're going to talk about common number functions that you might want to think about when we're utilizing it. So that's going to be our next section here. So let's go ahead and talk about it. All right, as I said, let's go over some common number functions. But before I do that, I just noticed that I totally misspelled positive, and that kind of bothers me when I make the video. But anyways, we want this to be positive. So let me get rid of this, and we'll do the same thing down here. Even though we weren't referencing it, it's still highlighted blue for me. And that's a little spell check extension that I have on here. Positive. There we go. And I think that cleared it all up. I think I misspelled it up here as well. So anyways, some common number functions. Again, we may have to think back to our algebra days and stuff, but ES, right? That stands for absolute. It returns the absolute value. And in math, right, we were always taught that, hey, no matter if it's negative or positive, it's always going to give a positive result. So that is what the ABS does. And we can test this out here with, let's go ahead and just do a test number. And we're going to utilize minus 7.5. And down here, we can do absolute value. And we can put in the test number in there. And then, of course, we can print it to test this out. And then we're going to go ahead and run it. And notice that it did remove the negative sign on there. And again, I'm going to go ahead and expand this just a little bit so it's easier to read for you all. Next, we're going to try the round. So let's see what the round does for us. Round number. And then we're going to throw in our test number. So save that. And then let's go ahead and print it out. And then we're going to run it. Let's see what we get. We get -8. So you can see that it did round up. The other thing that we're going to try on here is what if we wanted to make this an integer? And remember the difference between an integer as well as a float, right? Integers will just make it without the decimal point. So let's see what we get with that. Integer number, and let's go ahead and print the integer number. And we'll run this, and we get -7. So it didn't round it, it just chopped it off, right? And then, of course, if we do a float, let's see what happens when we do float number. This time we're going to take integer number that we just got done, and then we're going to print it. Otherwise, we really wouldn't see that much of an effect over here, utilizing the float on our test number. So let's go ahead and let me scroll up for it and run it, and we get a -7.0. So it just added the .0 on there for us. So in conclusion here, whenever we're talking about numbers and performing math on it, it's just something extra to think about. We need to understand the different types of numbers that we have. We need to practice more with our arithmetic. And again, we have some examples here, and then we're also going to throw in a challenge for you all to try. So make sure that you go through it to help solidify what we just learned with it. It's just going to take you practice getting through those numbers and the theory behind these. So we'll see you in the next video. Right, in this video, we're going to be talking about type conversion. And in the previous couple of videos, we learned that there's strings. We've learned that there's numbers, and numbers can be broken down into two different parts here that we're focusing on, which are integers and floats. So why would we need to convert types? Well, you're going to be taking user input, or maybe you have a string that has a number inside of it, and we would like to add it to a real integer or a real float. And how do we convert that string to an integer so that way we can add them together? Now, Python comes with two types of basically conversions. One is implicit, the other one is explicit. Now, before we get into too much detail with this, I do want us to take some notes. So let's go ahead and dive into Visual Studio Code and see how our files are set up. All right, so we're inside Visual Studio Code. I have my file folder set up here in our Python folder. We have lessons, and inside lessons, we have the type conversion.py. All right, so let's go ahead and take some notes here. As you can see, I have some stuff written on here already, and we're talking about type conversion. Type conversion is the process of converting the value of one data type, whether that be an integer, a string, a float, etc., to another data type. Now, like we were talking about earlier, there's two types of conversion. There's implicit conversion, and then there's explicit type conversion. So let's go ahead and type out some examples here. And I'm going to start off with just a simple integer. And we're going to talk first about the implicit, meaning that it's going to do this for us without having to change any kind of property. And we're also going to give you a brand new method out there for us to check to see what type of data are we dealing with. So first we'll do num int equals 1, 2, 3, right? This is an integer, right? It's not a float. There's no decimal points. Next, we're going to do num flow, and we're going to set that to 1.123. Now, we have two different data types in this case. And let's go ahead and show you that we do have a data type of an integer and we have a data type of a float. But before we do that, let's go ahead and do this. We'll do new, and we're just going to add them together. But let's go ahead and show you that we can tap into the data type of each one of these. The way that we're going to do this, we're going to do print, and then we're going to do data type of num int, and then we want to wrap the num int. If you take a look at this right here, make my arrow here, we're going to wrap that in this method here called type. So if we wrap it in the type, it's going to take our num int, and Python gives this to us for free, and it's going to tell us what data type it is. So let's go ahead and save that and run it here. And go ahead and ignore the class part for now, but right here it tells us that it is an int, an integer. Let's do the same thing for the num flow. Print data type num flow. And again, we're just doing the same exact thing that we did on line 13. We're doing that on 14, but this time it's to the num flow. So if I go ahead and save that and run it, notice that it is a float. So now we know that we have these two different data types. Now the question that we have to ask ourselves, when we add them together, are we going to get any error? Well, obviously it doesn't have any error because we've been playing around with this for the past couple minutes here, and it would automatically read this and tell you whether or not it throws an error or not. So to show you what the new num is, let's go ahead and save that and run it. And we can see that the value on there is 124.23. And that should signify to you that this is no longer an integer. It's no longer a whole number. It is an integer because it has a decimal point. Okay. So that's what we're talking about here when we're saying, hey, Python behind the scenes here is recognizing that this is a data type of integer. And this one right here is a float. And it says, hey, you know what? A float's a higher priority. So we're going to have some data type integrity, and we're going to convert our answer to a float as well. So that's all that is saying whenever we're doing the implicit type of conversion. Now let's go ahead and let's do one where we have to explicitly say that, hey, we need you to be a certain type. So that's what we're going to do next. Right, so we have the explicit type for the conversion here. And this is where you, the programmer, you actually have to convert from one data type to another utilizing some conversion functions or methods. So how are we going to demonstrate this? Well, in this example, we're going to have an integer, and then we're going to try to add it to a string that looks like an integer to us, but it's really a string in reality. And so what do I mean by that? Well, let's go ahead and do a num int. We're going to make that 1, 2, 3. And then we're going to do a string version of this. And we're just going to do 4, 5, and 6. So as us, a human reader, this looks like a number. It has numbers in it. But to a computer, it is of type string. And again, we can verify this. We can validate it. And so I'm just going to do the data type of num int. And then I'm going to do the same thing for the string. And because we have some code up above, I don't want it to get cluttered over here. You are able to highlight the code, and then you can hit the play button in order to run it, and it will just run it. So as we can see, our data type for the first one is an integer. The next one's a string. All right, now let's go ahead and try to add them together and see what we get. So we're going to go ahead and do the following here. We'll do total equals num int plus num string. So now if we save this and highlight this, we are in fact going to get an error, and we get a type error. It's unsupported, an integer and a string. We can see that right here, integer and a string. So what is the fix? Again, this is where we have to include some programmer to manually convert this over string to an integer. And so one of the things that we have available to us is we have something called the int, and then we can apply this to the string version, and now we can go ahead and print the total. And if we run this time, we now get the answer here, which is 579. So that is where we're manually going to have to convert the string to an integer. Of course, if you needed a float, for example, if we did this, we'll do 0.5. Now, if we went ahead and ran it, so we're going to get an error. And that's because what we supplied it is not an integer. But instead, we can make this a float, and we're going to save it. And let's go ahead and run it. And now we get the 579.5 that we see right here. So let's go ahead and we can make some notes here with the different types that we have available to us for converting. So we'll make this a comment here, and we'll say version types, and then we'll go ahead and do an int converts to an integer. Then we have the float. It will convert it to a floating point number. We do have the ability to convert a number to a string, for example, and we do have other ones available to us. You can go ahead and scroll down at the bottom of this video. We have a few more to go over, or that you could go over. We haven't really talked about Booleans quite yet, so I didn't want to cover that in this video. But there are example types down below going into a little bit more detail, but feel free to wait until we go through the video module for Booleans before you get to that part, right? So we'll see you in the next video. In this video, we're going to be talking about Booleans and when you should use them. We're also going to dive a little bit into some comparison operators that are within Python as well. So let's go ahead and go to Visual Studio Code so we can see the file set up in it. I have it set up right now with the Python lessons, and then inside there I have something here called Booleans. And as far as the notes go here for it, obviously we've dealt with the other primitive types, which are numbers as well as strings. This is the last and final primitive data type that we're going to use and talk about. But Boolean, it's really simple. It has two values. It's either true or it's false. It's just like a light switch. It's either on or it's off. There's no in between. And the way that we're going to signify Boolean values is the following. And let's go ahead and create a variable here called is raining. And then we're going to set that equal to being true. So notice that the true on here, we have a capital T. That's very important. It's either going to be a capital T with a true or a capital F for a false. So think of a weather app, for example, and we're getting some information from the weather reader, and it's talking about the weather forecast. And we have this keyword up here called is, right? Now, again, we could name this anything that we want. It's totally arbitrary. But usually when you are creating Boolean type of variables, you always want to have something in here that's telling the developer that this could be something truthy or falsy. Is raining, is sunny, is logged in. Those types of things are going to be very important when you come to variable naming. So let's go ahead and do an example of a false. We'll do is sunny, and we're going to set that to false. So those are your examples. Again, Boolean part, that's the simple, most easiest data type. It's either true or false, 0 or 1. For example. Now let's go ahead and talk about comparison operators. And one of the things that you're going to find when you are starting your programming career here is that whenever we have a decision to be made, we're going to go down one path or another. Usually it's based off of some sort of comparison, some sort of value. And I mean, we do this all the time in our own daily lives, meaning that if we come up to a red stoplight, well, what do? Well, we stop the car, right? We push the brakes. Just like it, we just made a decision based off of something that's going on in our environment. So these comparison operators just by themselves are going to report something that could be truthy or falsy. So again, comparison operators are used to compare two values. They will return a Boolean value. And there are comparison operators out there. And again, we're kind of dipping back into our math, right? where we have greater than, less than, equal to, not equal to. Then those are the things that we're talking about here. So the first one that we're going to deal with here is going to be the greater than. And greater than operator looks exactly just like you've learned about it in high school, right? You have this little symbol here, which is the greater than symbol. And so if we come over here and we are comparing two numbers, again, as a human, we can read this, right? Is 5 larger than 3? Yeah, we just compared the two and it happens to be true. So let me go ahead and run this and we can see that it is in fact true. Well, let's take a look at the false statement, and which is just the opposite. Is 3 greater than 5? Well, again, that's going to be false. Now we can also, some people try to do this with strings. Can you see if a string is greater than another one? And this would be probably for sorting purposes. And if I do something like this, print, and then is apple, right? Is apple greater than banana, meaning that is apple higher on the alphabetical list than banana. And we're going to save this and we're going to run it. We get false, right? Because A is not greater than B. And the reason that this is coming true, and again, I don't expect you all to know this or anything like that, but each one of these letters here is assigned a value, is assigned a number. And that's what it's really comparing when it compares to strings. So this is only useful when we're talking about sorting. If we take a look at this other example here, and again, uppercase, lowercase, they do matter. And if we run this, I get false. Well, again, why are we getting false? I'm going to do a print here, and I'm going to do an ORD of the capital letter A, just to show you what is the value that it is picking up based off of the apple part, right? And if we look at this and save it here, there we go. We get 65. Well, what about the lowercase a? Let's look at it. And so in computer lingo, it is assigned the value of 97. And so again, when we're comparing these strings, when we're comparing these, that is why we're getting expected values that we are for truthy and falsy. So just know that in the back of your mind, that if we're going to be utilizing something like this, they all need to be lowercase for sorting purposes. Now, of course, we have greater than or equal to, and let's take a look at what that looks like. So whenever we're utilizing it, again, we're just doing the greater than or equal to, and then we're comparing it, just like we did in math class before. Is 5 greater than or equal to 5? Well, that's true. So that's going to return true. Same thing for is 5 greater than or equal to 3? Okay. So if we save this, run it, we're going to see that we get true, false. All right. I'm going to go ahead and copy and paste this just to show you what the opposites look like. And so this is going to be your less than, and then we also have your less than or equal to. Hopefully those are going to be self-explanatory to you. Now, the equal case. So what if we have two values that we're trying to compare that are equal? Well, let's take a look at how we would represent it. So if we're talking about numbers, we're going to utilize a double equal sign. The reason that we're utilizing the double equal sign instead of just a single one is because we're not trying to assign it a value. We're trying to compare. That's going to be the main difference, right? Now, of course, you can also compare strings. I think we've talked a little bit about that before in a previous video, but just to give you an idea of what that looks like, go ahead and add an extra space here. But this is for the strings, right? And so something that I want to bring to your attention with this is, let's look at this. Hey, is this exactly the same, right? Double equal signs. That's what I want you to remember, double equal signs. But look at the characters, right? Are they all lowercase? Because when we come down here to my line 40, this is going to return false. And why is it return false? Well, that's because this H right here is an uppercase, right? And it goes right back to applying numerical values to these to catch them up. But anyways, it is looking at the string itself. Uppercases are treated differently than lower cases, which is why we get a false representation from that Boolean comparison check. All right, now the last operator that we have to talk about is, what about the not equal? So the way that we go about it is we utilize an exclamation mark and then a single equal sign. And so that's going to be the main difference on this one. So if we look here, we have the exclamation mark and then an equal, and then that is represented right here with the false. And then we also have is 5 not equal to 3? That happens to be true. And that's the way that you have to read this. Maybe reading it out loud is the best way to help you out when you're first starting to learn this. Is 5 not equal to 5? Nope, that's wrong because those are equal. Oh, is 5 not equal to 3? That's a true statement. And then the same thing goes for the string version as well. So let's go ahead and take a look at it. And again, this may be a little confusing, but just try to read it out loud. Print hello, so all lowercase hello, is that not equal to all lowercase hello? Nope, they're equal. Same thing over here, hello, and then the world, are those not equal? That is true. So again, the not equal seems to be always the confusing part when it comes to students when they're learning how to program with this. But anyways, make sure that you revisit this video, and of course, you're going to be challenged in the future. And we're getting ready to do conditional statements, and it's going to be very imperative for you to recognize what these conditional operators do and look like. So we'll see you in the next video. Right, in this video here, we're going to be talking about logical operators, and this is where we're going to be combining 2 or more conditional operators in order to provide some conditional logic, right? So we're doing a lot of things here all in one type of setting, but let's go ahead and dig into Visual Studio Code. We are in the Python folder. Inside there, we have lessons. Inside lessons, we have logicaloperators.py. Now, logical operators, they're used to combine different 2 or more conditional statements that would result in something being true or something being false. And the ways that we can combine these is utilizing AND statements as well as OR statements. And so a way that I'm going to be demonstrating this to you, again, just let's say we are in a make-believe country, and part of their tax system here is in order to get a tax credit, you need to have a child. And the next option on here is that child has to be greater than 18, has to be above 18. And so we can go ahead and apply some of this to variables and then have our conditional logic evaluate it. So let's go ahead and have something that says has children, and we're going to set that equal to true. So this person has children. Now we need to make sure that they have children that are less than 18 years of old. And so I'm just going to create a variable here that is under 18, and we're going to set that to false. So the children are all grown up, and they do not get to have a tax credit based upon these 2 options. So for that, we're going to say if, and then we're going to say has children. So if has children is true and is under 18, we're going to go ahead and print you are eligible for a tax credit. All right. And then we can say otherwise you are not eligible for the tax credit. So if we go ahead and save this and then we run it, it says you are not eligible for a tax credit. Now let's go ahead and run through this logically. Has children is true. So this part here is true. Then we can come down here and look at it. Is 18, is that true or false? Well, it's false. So both of these conditions have to be true in order for this to happen. Maybe another way for you to look at this would be if I were to put 2 equal signs here and I were to put true and the same thing here, and this would equate to the exact same thing if we were to run this. But by cutting down some of the code, we can totally remove the equals true on both sides because that's what we're evaluating, right? If we were to print has children, we would see it's true. So anyways, either way is fine, but as you get progressive in your coding, you're going to typically refactor this to simply do this. All right, let's do another one where it's OR. We're going to utilize the OR operator. And for this to work, we're going to say, hey, you know what? In order to get a discount, you either have to be a student or you have to be a senior citizen. So we're going to say, is student equals true? That is true, right? Or the senior citizen, is it true? Okay, so we're going to do both of them here. And let's go ahead and make our if statements. So we're going to say if student or is senior citizen, then we're going to go ahead and print you are eligible for a discount. Else, you are not eligible for a discount. All right, so somebody's coming through my lane here, and this senior citizen happens to be a student as well, but it really doesn't matter because they match one of the cases. So I'm going to go ahead and save it, run it. You are eligible for a discount. If I say, hey, this senior citizen that came through my lane, you're not a student, but you are a senior citizen, let's go ahead and run that. And again, it doesn't change. If both of these are false, we save it. Now we can go ahead and run it. And it says that you are not eligible for a discount. So these are the cases that we're going to try to instill in you when we're utilizing conditional logic, and we have multiple things that we care about to determine what path do we want to take. It's very similar to things in life, meaning that if you see a light turn yellow, you're running in your mind a lot of things such as, should I stop or should I slow down? Should I keep on going, right? Those are the things that are coming through your mind, but based upon the conditional environments, you make a different decision. So, hey, are there any cops around, right? That might factor into the decision making. Oh, if there's a cop, I'm definitely stopping at this yellow light, right? Or, hey, I don't see any cars going left and right. I'm going to keep on going, right? So there's multiple conditions that you might want to think about, right? Hey, there's nobody around, but I see a cop. Cop's always going to overrule you, and you're probably going to stop. So these are the things that we're trying to start to get you to think about when we're talking about conditionals and then utilizing these logical operators with the and or statements. So use what you learned here in this video and apply it to our next challenge. All right. Right. So we're going to be learning more about conditional logic when it comes to all the things that we've learned so far with the comparison operators, right? Something that provides us with a true or false type of logic. And so inside Visual Studio Code here, I have the file set up here as Python. Inside there, I have lessons. Inside lessons, I have something here called conditionals.py. Now, like I said earlier, that the conditionals, now we're actually following a path based upon something being truthy or falsy. This is where we're going to be coming up with if statements. We also have else statements, and then we also have else if. It looks like an elif, right, statement, and that just tells us that it's going to be an else if. So one of the important notes when we are doing this logic, a lot of times in programming languages, they'll use curly brackets in order to scope out certain pieces of code. And this right here, Python utilizes indentation. So as we're going through this, and if you're running into any kind of errors, it might be related to the indentation. A lot of students that I see, that I help, indentation is typically the problem. Now, our auto formatter should help us take care of the indentation, but in many cases, it may not if you're running into any kind of errors. So not only does syntax matter, but indentation matters to know what type of block scope are we going to be executing some code here. So let's go ahead and get started with some code here. And we're going to start off with a very simple if statement. So we'll put a hashtag here and we'll do an if statement. And let's go ahead and set the temperature, and we're going to set that to 30. Now let's make a simple if statement that says, if the temperature is greater than 25, then print, it's a hot day. Now, this is going to be in Celsius, right? So let's go ahead and do if temperature is greater than 25, print, it's a hot day. Now, notice that we do need to include at the end of our if statement this little colon here. That's a colon if you can't see it. So it's going to be a colon. That means we are done with our thought for this line. And then we're going to move on to the next line, and it needs to be indented. Your editor might have it only go 2 space over. That's an indentation. However, with mine, and because if you set it up correctly with our setup that we had to do, it should put in, I believe, 4 spaces for the tab. But notice that this right here, we have a semicolon, and then we have it indented right here, which means that anything that is indented will be executed if this statement turns out to be true. So let's go through this from a code point of view. we're setting temperature down to 30. Is 30 greater than 25? If it is, we're going to run into this right here. If it doesn't match this condition, right? If it doesn't match this condition here, then it's going to bypass all the indentations. And that's the beauty of the if statement. So let's go ahead and save this, run it, and we can see that it's a hot day. If we change this to 15, save it, run it, notice that we don't get anything printed to the console because we don't have an alternative. Now, let's go ahead and talk about, I'll go ahead and move this back up to 30. Well, what if we want to execute more lines of code after the if statement? Because maybe you're going to have several different statements here. We're just going to simplify this to something like, hey, if it's greater than 25, it's a hot day and you should wear some shorts. So let's go ahead and print, you should wear shorts. So now if we save this and we run it, notice that we get both print statements. Notice that it's executing both of these, and that's because we have it indented. Let me go ahead and demonstrate to you now. If I go ahead and change this to 15, if I save it and run it, I don't get anything. But if I remove this indentation that we have here, it's outside of that code block, and it's going to print out the statement here. So that's why I wanted to stress to you all that indentation is so important when we're talking about these conditionals. It's going to execute this block of code. All right, let's go ahead and talk about the if and else statements next. All right, so let's go ahead and section this off here, and we'll do using the if and else statement. So for this, what we're going to do is we're going to have the temperature, we'll set it to 25, and then we're going to have an if statement again, but just like what we had before. If it's greater than 25, we're going to print it's a hot day, and then we're going to do an else, and then we're going to print it's a cold day, and then we can also put in here, you should wear pants. All right. So as you can see, we have a couple things going on here. We are block scoping things. Please make sure that you indicate at the end of your if statement, you have the colon. That's not a semicolon, it's a colon, very important. And then we have two print statements. Notice that it's all captured within that block of code there. And when I say block of code, I'm talking about things like this. This is a block of code. And then over here, this is a block of code as well. So I'm going to go ahead and save this. And just so that I don't get any interference from the above if statements, I'm going to go ahead and highlight this, and I'm going to go ahead and run it. So we can see that it's a cold day and you should wear pants. Why did we get that? Well, let's kind of go through this again, just like the computer program. Our temperature is set to 25, and we come down to this if statement. Is 25 greater than 25? It's not. So it's totally going to ignore this code block right here. And it's going to move on to the else statement. So feel free to play around with this. Of course, we can alter this number, change it to 35, and see what you get. But again, this is going to be a real great use case, whether you have an A option or a B option. It's almost like you have a decision point and it's a split, and you have to pick which way you want to go in your logic. Think about potential use cases. Hey, is the game over? Did the time run out? Did somebody get all the points, right? Hey, the first person to 50 wins, right? If it's greater than or equal to 50, the game is ending, right? So all these neat things that you can do with these if statements. All right, let's go ahead and talk next about the if and then the else. That should be a good one to follow through with. All right, so let's go ahead and look at it. We're going to be utilizing the if, the else if, and the else statement. Again, in Python, instead of saying else if, it's going to be elif. That's the way that one is talked about here. All right, let's go ahead and do the same thing that we've been doing before, just so that we can have everything in the same view. We're going to do temperature. We're going to set that equal to 20. And then we're going to say if the temperature is greater than 25, let's go ahead and print it's a hot day. You should wear shorts. I'll go ahead and scroll up for us. And then we're going to do an else if, right? An elif. And the thing that we want to note on this is the indentation on it, just like we did with the else statement above. Notice that they are flushed in their line. So the else if gets that same treatment, followed by a colon. And then whatever goes underneath here is going to be the following. we're going to print, it's a cold day, you should wear pants. And then the last statement here is catch all. And we're just going to say, it's a nice day, you should wear a t-shirt. Okay, so if we think about this logically, right, the temperature here is 20. We're going to go down this rabbit hole here, and we get down to the temperature. So temperatures here is 20 greater than 25. It's not. It's going to move on to the next one. Is 20 less than 20? It's not. And then the last one here is, it's like a catch-all. If it doesn't match these two, then it's going to fall into here, right? So hopefully that makes sense. So if we go ahead and save it and run it, we get, it's a nice day, you should wear a t-shirt. And let me go ahead and just highlight this part here and run it. It's a nice day, you should wear a t-shirt. That's what we're trying to get at here. All right, so we have a couple mini challenges in this video, which is exciting. So let's go ahead and try out mini challenge number 1. This is where you're going to pause the video. I'm going to give you the prompt. You're going to pause the video and let's see if you can complete it. So here's your mini challenge that I would like you to try. So go ahead and save that. Go ahead and write an if-else statement that if it's raining, you should take an umbrella. Else, you want it to print, you don't need an umbrella. And let's go ahead and create a variable called is raining. Go ahead and do that. Pause the video and see if you can get it. All right. Hopefully you ended up getting this. So we're going to do the following. We're going to do is raining, and we're going to set that equal to true just to test it out. And then we can say if is raining, colon. Then we're going to do this print, you should take an umbrella. Else, you don't need an umbrella. So let's go ahead and save that, and I'm going to highlight it and run it. It says you should take an umbrella. If I change this to false, save it, and run it, you don't need an umbrella. Perfect. Great. That seemed to work. All right, let's try our second mini challenge. And this is going to relate to maybe purchasing a movie ticket. And so here's our challenge. Based on the age, print the following message. If the age is older than or equal to 65, print you're getting a senior movie ticket. If the age is between 18 and 64, go ahead and print out you're getting an adult movie ticket. And then anything else, you can go ahead and put you're getting a child ticket. So let's go ahead and pause the video, see if you can create something like this. Just to let you know, I'm going to be utilizing the variable called age as what I'm going to provide for my testing. All right, hopefully you ended up getting this one. The way that I'm going to approach this, I'm going to do age equals 30, and then I'm going to come down here. If the age is greater than or equal to 65, I'm going to work with that case first. I'm going to print out you're getting a senior movie ticket. Else, right? If we are greater than or equal to 18, we're going to go ahead and print out you're getting an adult movie ticket. And then the last case here, you're getting a child's ticket. Go ahead and save that and test out all the use cases on it. So between 30 and 65, we're getting perfect, an adult movie ticket. If I do 65, save it, run it, you're getting a senior movie ticket. And then lastly, let's go ahead and test out that one use case. We're going to say you're 8 years old, and we're going to highlight it and run it. You're getting a child ticket. Hopefully, with more practice, you're going to get this. We're going to dive deeper into more conditional statements when we're talking about logical operators. That's what's going to be next, and a good challenge you and one of your best friends to try out. So that's going to be up next in a few videos. Right, in this video, we're going to be talking about the ternary operator, and it's something that's very unique. You're going to have to think a little bit about it before you use it. It's a real quick one-liner code that can definitely make your code look a lot cleaner. We're going to show you how we're going to go from maybe 4 or 5 lines down to maybe 3 lines, and it's just a real slick way to kind of do a real quick, simple if-else check, right? So let's go ahead, dive into Visual Studio Code here. And you can see that I have my setup here, Python lessons, ternary operator. That's how you pronounce that, ternary operator. And again, the ternary operator is a conditional operator that returns a value. So it doesn't have to be truthy, falsy, or anything like that, but it just returns a value based upon the condition. And I think the best way to think about this is, let's take a look at a generic if statement, and then we're going to show you how slick it is to have a ternary do the work rather than an if-else statement. So with that being said, we're going to go ahead and convert an if statement, an if-else statement to a ternary operator utilizing this simple structure. So let's first get the in here. We're going to set that at 20. Next, we're going to come up with an if statement saying, if we are older than or equal to 18, we're going to print out you're an adult. So print you're an adult. Else, we're going to go ahead and print out you're a minor. Now, again, if we save this, run this, this is what we've been doing so far in your modules, in your lectures. This should be second nature to you of understanding what's going on. All right, so here comes the tricky part. Well, not so tricky, but you'll have to just do a little bit of thinking about it. So we're going to, again, set the age to 20. And I want to put both of these up here real quick, just so that we can take a look at exactly what's going on. So we need to break this up into a couple things. We want to say, hey, the message that we want to have is either you are an adult or you're a minor, right? Those are our only two options. And so what we're going to do is we're going to throw in at the very beginning, what would you like to have happen if it is true? So if it is true, if our condition is true. So let's go ahead and put that. I want to have it say you're an adult. If it's true, it's an adult, right? And so then we put our condition in there. So we're going to go ahead and put this in here. I know it looks a little bit smashed. Let me go ahead and make this a little bit bigger here. And then at the end of this line is where we're going to put this else. So we're say if age is greater than or equal to 18, this is what's going to be happening if it is true. Else, well, what do we want? You are a minor. And again, if we look at our notes, it says the ternary operator is a conditional operator that returns a value. And so this is the value that it's returning if it's true. So I always think of this, hey, we're on a balance scale here, and whatever's on the left side will happen if it becomes true, if this statement here is true. Otherwise, whatever it will happen, it will fall down in the else clause here. So let's go ahead and save this. Let's run this. We're not going to see any difference in our console. We forgot to print it. So let me go ahead and print the message, and then we'll save that and run it. You are an adult. If I change this to 14, save it, and we're going to go ahead and run it. You are a minor. So again, it's a real quick one-line zinger that kind of sets us up, and it's almost like human readable too. And that's what I love about this is you're an adult if your age is greater than or equal to 18, else or otherwise, you are a minor. Now, you are able to continue this on and daisy chain on some more things, but it is frowned upon from a developer's point of view because it's not going to read properly. So if you are getting into daisy chaining these ternaries, it would not be wise as far as a code review goes. All right, so let's go ahead and take this just a little bit further with a little more practice with a ternary. And I have a little miniature challenge here for us. So say that we're at a school and we're writing some software, and the passing grade for this class or this school is getting a 50 or above. We're going to set the student's current grade to be 80, and we would like you to utilize a ternary to determine whether or not they are passing. Now, we don't want you to print it. We just want to be true or false. So let's go through this together with this little miniature challenge here. Again, we're going to set up our initial grade value. We're going to set that equal to 80. All right, so that part's easy. Now, the next thing that we would like to do is let's set up a new variable called isPassing. And again, we're going to set this up in a way where it gives us a Boolean, whether that be true or false. So if we say that we want true on the left, if, again, we're just trying to write this as if we were reading it in English, you are passing. It's true that you are passing if your grade is above or equal to 50. Otherwise, you're not passing. It's false, right? So that is our statement. And so we can go ahead and test this out. We're going to print is passing, save it, and I'm going to highlight this and run it. And we get back true, you are passing. Now, let's go ahead and write out some if statements to reinforce what we've learned before. And here is our stipulations for the next part here. So evaluate the student's grade. If the student has passed, go ahead and print out student passed. Otherwise, print out the following, which is in the future here, we're going to be talking about other things, but hey, these are some things that we need to do. We need to email the parent, we need to notify the principal, and we can notify the teacher because we're writing this code. As soon as someone has inputted the grade of the student, if they are failing, we would like to have all these notifications to go out based upon the evaluation of their grade. So let's go ahead and do that with an if statement. So we learned that we could type out if is passing is true, then I want to do the following. I want to print out that the student has passed. Else, well, what do we want to do? Well, we want to email the parent, we want to notify the principal, and we want to notify the teacher. Now, maybe once you have typed this all out, go ahead and pause the video and say, hey, is there a way that this could be refactored, still keeping it an if statement based upon what we talked about earlier with the logical operators? Well, hopefully you realize that this part right here is not necessary, and we could totally remove it, and it would still have the same meaning. And let's go ahead and go through this logically, line by line. We're evaluating it, whether it's true or false. We've realized by printing it out to our console, it is in fact true. If is passing is true, go ahead and print out student has passed. Otherwise, we want to go down this rabbit hole. So we're going to go down this one, right? So if I go ahead and save everything and highlight this and run it, it says student has passed. Perfect. Well, let's go ahead and change the score up here to a 20. We can save it, highlight it, and run it. Turns out it's false. Now we're going to email the parent, notify the principal, notify the teacher, right? So hopefully you ended up getting that little miniature challenge. Again, it's just going to be all about repetition, repetition, repetition when we're trying to go over these. Once we start getting into our projects that we're going to have here for the chapters, you're going to get a lot more practice with this. And that way you're able to meet with your tutor, meet with your mentor to go over these to re-solidify all of this. All right. So we'll see you in the next video. In this video, we're going to be talking about chaining comparison operators. This is going to be a real short video, just going over how you can potentially simplify some code if you ever run into this situation. Or maybe you're looking at somebody else's code and you're wondering, oh, I didn't know that you could do that. So that's what we're going to talk about in this one. So inside Visual Studio Code here, I'm going to go ahead and show you our file folder setup, Python lessons chaining comparisons.py. So what I'm going to do is I'm going to go ahead and collapse this, but chaining comparison operators is a way to compare multiple items at once and a way to simplify your code if you want to do so. Again, both ways that we're going to show you and how to do this would be fine. However, it's going to be your preference on which one you'd like to use. So what do we mean? Let's go ahead and take an age of, we'll say 22. And we want to have an age range is if the age range is between 18 and 65, let's go ahead and print something to the console. So we're going to say if the age is greater than 18 and the age is less than 65, go ahead and print this to the console. So if we evaluate this as is, 22 is between 18 and 65, and we can go ahead and save that and run it, and it works just fine. Again, this way is perfectly fine. However, if you are looking at chaining some comparisons, if you remember in math class, if we were to simply take the following example here and say if 18 is less than the age, but also less than 65. So, we're just saying, hey, is the age is it in between these two ranges here? Again, this is perfect syntax. And just to demonstrate that we can print something that corresponds with that if statement, we'll go ahead and I'll move this down, or I'll just copy this real quick, just so I can select it. But if I go ahead and highlight this, save it, run it, you are between the ages of 8 and 65 years old. So again, I just wanted to point that out to you in case you do see it. You are able to write it in code just like this. Other languages, you'll have to typically use this. However, in Python, they do allow you to chain these or combine the two into one for the comparison to do its test. All right. So see you in the next video. In this video, we're going to be talking about loops. In this video, we're going to be talking about loops. All right, hopefully you got that joke. We're going to be talking about loops in this, and it's going to be a real simple concept. We're going to go over a lot of little miniature challenges in this to hopefully solidify some of the concepts with loops and what they do. Let's go ahead and go inside of the S code here. And inside here, I have my Python folder. I have lessons, and inside here, I have loops.py. So we're just going to talk about the for loops in this video here. And loops are just used to repeat a block of code multiple times and over and over. And you get to tell it how many times that you would like to go through it. So we're going to provide you with a few thought cases on utilizing it and demonstrating it and such. So let's go ahead and get started. I'm going to go ahead and collapse this, give us a little more room. And the very first example that we're going to do is I just want to print to the console 5 times. And in this scenario here, the keywords that we need to type in here in order to get this to work is going to be the keyword for. So I'm going to go ahead and type in 4 in there. And then usually there's going to be a variable. Again, this can be arbitrary. It really doesn't matter what it is, but it's traditionally I for incrementer. So I'm going to say for I, and then you're going to use that keyword in. And that is going to tell Python, hey, I have a variable here and it's going to increment and we need to provide it a range. And so if I type in range of 5 and I'm going to put a colon on here, again, we're talking about having our tabs, right? So make sure you're indented here. And we just want to print I. Let's see what happens here. So I'm going to hit the play button here and notice that we get a 0 here and then a 1, 2, 3, 4. But I told this thing to go 5 times. How many times did it go? It did go 5. But just remember that in computer language, we start off with 0. So we're starting off at 0. So a way to kind of think about this is anything that's in the indented space here underneath the for loop, every single thing to get ran underneath this. And it's starting off at I being 0. And then we have this range here saying, hey, how long do we want to keep doing this for? So it is interesting that it does start at 0, right? Us as humans, we think that it's going to start at 1, but it doesn't. And so let's go ahead and do a little bit of a miniature challenge here and see what do we need to do in order to get the numbers to print from 1 to 10. So let's think about this. Let's do it in steps. And so I'm going to think out loud on how I want to approach this, and hopefully you're thinking about the same thing. And so I can do something like this. I know I need to have 10, right? I need to go from 1 to 10. So let me go ahead and start off my for I in range. I'm going to put 10 in here. And then of course I know I need my colon, and then I'm going to print I. And let me go ahead and play with this, save it, and I'm going to highlight this and run it. And I get 0 through 9. Well, how can I shift that by 1? That's going to be my thinking here. And I can go ahead and add plus here at the end of the I and just do +1. So now I can save this and run it. And now I get 1 through 10. So that is one way of doing it. So the range can have up to 3 parameters, but in this example here, we're going to try out 2 parameters this time. And instead of just supplying it 1 number, we're going to supply it 2 numbers, and it's going to be the start point and then the end point. So let's see what it looks like, because again, we can simulate what we just did on lines 11, on 10 and 11, and doing that utilizing a start and an end point. So we're going to try that again. We'll say for I in range, and then we're going to go ahead and do 1. Now this is where it gets a little bit tricky, because I want to show you what this looks like first. And then this is why we want to try out code, and it's okay to be wrong. And then we just need to adjust. So in my mind, right, I'm thinking 1 through 10. I just want to go 1 through 10. I want the start point to be 1 and the end point to be 10. And then I'm going to go ahead and print this. So now if I save this and I highlight this and run it, I get 1 through 9, 1 short. And the reason behind this is our stop point. This is when it's going through the loop process, and at the end of each iteration, it's checking to see, hey, are we at the end point yet? Oh, we are, because on that last time, it's actually 10. So it goes ahead and stops. So if we want to get that extra number on there, we have to go 1 over. And so we could do something like this where we hit the play button and run it. Let me go ahead and highlight and run just to show you that we get 1 through 10. So that is a second way of doing it with utilizing the range of a start point and an end point. Now, I'm going to throw a little mini challenge at us here. And this is where we're going to have to go from 1 to 10, but this time we only want to print the even. So let me go ahead and scroll up and post this one. And you may want to pause the video, go back to the expressions, and look at which expression do we have available to us that allows us to take the remainder, because that's how we're going to approach this, because we have to put some conditional thinking in our minds of, hey, I now have a new parameter here. I don't want to print 1 through 10. I only want to print if it's divisible by 2 and the remainder is 0. So see if you can go search and find it, pause the video, and then come back. We're going to go ahead and draw this out. Well, hopefully you ended up finding what that modulus looks like. And so we're going to do for I in range. And we already know from before we want 1 through 11. Now, I'm also going to put in here if modulus 2, right, equals 0. And what does that mean to us, right? That's saying, hey, let's say, for example, I is 2 divided by 2 is, right, with a remainder of what, right? So we get 0, so it's going to print it. Let's picture 4 in our minds, right? 4 divided by 2, and then what is the remainder? Oh, the remainder is 0. So we're going to go ahead and print it here. So that's going to be the logic behind this. We're going to go ahead and save it, and then highlight and run it, and we get 2, 4, 6, 8, 10. Perfect. That's what we ended up getting. That's what we need. Let's do another mini challenge, knowing that we know a little bit more about the range of the start point and end point. And this time we're going to create a mini challenge of a multiplication table for the number 5. So we're going to have this loop go through 5 times 1, 5 times 2, 3, 4, 5, 6, all the way up to 10. And then we want to display that. And so this is going to reinforce some of the special formatting strings that we saw earlier on in our videos with this. So again, we've already got some of the groundwork here that we're looking at, but let's go ahead and take this for what it is. Let's go ahead and solve this like a problem solving. So generate the multiplication for the table 5. So I'm going to say something like this. I'm going to say number equals 5, all right? Because that's going to be my starting point. And then I want to have a loop that multiplies this number and prints it out for me. So I'm going to say something like this. For I in range. Now we already know how to get 1 through 10 from our previous example, right? And then we're going to do something like this. We'll say, we're going to step this out. I know we can do this all in one line like what this code editor is trying to show me to do. But let's go ahead and stub this out by creating another variable. So we'll do product equals whatever our multiplication number is up here, and then we want to multiply that by I, right? So just think about this as we're going through the loop. I is 1, it starts off at 1, 1 times 5, and then whatever that result is, it's going to be stored in this variable. And so then we can print something like this. We can go print, and then we want the F, curly boy, right here, curly boy number. And then this is just a normal X from the keyboard, and then times the I, since we're in the loop, and then it's going to equal our product that we stored right here on my line 29, right? So let's go ahead and save that, run it, and then we're going to be able to see our multiplication table that we just created from 1 through 10 of multiplying by 5. Again, we made some nice reusable code here, so go ahead and test out 9. All right, let's go ahead and save that and run it. You can put any number that you'd want in there. And our loop is going to adjust and print out the proper numbers and the proper values. It's pretty cool, pretty cool. Now, the last part that I would like to talk about here involving range is that it can, like I mentioned before, now we have a start, we have a stop, and then we have a step. I know that's a lot of S's, but we're going to try to break this down here for you. Maybe, just like before, I put a stipulation in this last one where a mini challenge to print the even numbers from 1 through 10. Now, you could do this without using this modulus, but I put the stipulation in here that you use an if statement. So let's try doing that exact same thing without an if statement, showing you that we can go from 0 all the way to 100, and we can just do the evens. So watch this. I'm going to go ahead and scroll up just a little bit. I'm going to do for I in, and we're going to do from 0 to 100. And then this is where our step is. The step means how many are you incrementing each time you go through the loop. All right. That might be a little confusing, but just think that if we're starting off with 0 right here, once we get done with this loop, we're going to add 2 to that number. We're going to add 2 to I, right? So 0 plus 2 is 2. And then after it gets done with the 2, then it goes to the 4, and then the 6, and so on. So let's go ahead and demonstrate that real quick, and then we can just do a print I and save this. And let's go ahead and run this. So as you can see, we got zeros, and we have all the even numbers. And it doesn't go all 100. Again, that's why we test things out. If we go up to, doesn't matter, 101 or 102, if we save that, run it, we get all the way up to 100. So that is the range where it takes 3 arguments. Now, another neat thing that we can do with this is the step. And again, we got some examples below this video for you to go through that we didn't cover in this video. But one of the ones that I wanted to show you is we can also do a negative step. We can step backwards. So mini challenge, let's count backwards from 10 all the way down to 1. And what that would look like here is for I in range, we want to start at 10. So we want to start all the way at the top. And then we want to go all the way to 0, but we want to go minus 1, right? So now we just created a quick little countdown, right? Go ahead and save that, highlight, and run it. And now we got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So that will give you from 10 down to 1, nice little countdown. But loops, it's going to take you just a little bit to understand the loops. There's different types of loops that we didn't cover in this. It's going to be covered in different modules, but it also works on strings and lists and everything. So just know that you're not done with loops. You're not going to stop seeing loops, and they're just going to be part of your programming. So take a look at the examples that we had below this video. Please take a look at those and go through them and copy and paste them and make sure that you can understand them in the next video. So we just got done watching for loops, and in this example here, there's just a little bit that we can add to it called a for else loop. And it's an interesting concept. Let's go ahead and dive right into the code. I got a few notes here for us to work with. And again, I'm in the Python folder, and inside the Python folder under lessons, I have a new file here called for else loops.py. So the for else loops, they're used to execute a block of code when the loop has finished. All right. And I'll provide you with a few examples here, and then I'll provide you with maybe a real world type of example that we can go through as a little miniature challenge to go through this. It's just to let you know that to be aware that you do have a use case for a for else loop. All right, so let's go ahead and get started with this example here. And again, we're just trying to work on the basics here. And I'm going to start off here with an example 1, and I'm going to do for I in range of 5. And right now, I just want to reharp on the basics of thinking. You as a student, as a learner of this, start thinking in your mind how this is going to play out. What is this going to do? And so as soon as I hit the run button, we get 0 through 4. So what if we would like to have a use case here of printing something saying like loop has finished executing at the end of the loop? And if I were to simply just put it inside of the loop, that's not going to be good, because we're going to see this thing 5 times. So if I hit the run button, we can see that we see it 5 times. We don't want to see that 5 times. The loop hasn't finished running. It's still as we're going through this. So that's where we can come in here with an else. And again, something that we're looking for here is the indentation, right? If this is all the way to the left, then the else has to match it for the Python to consider this an else statement for the for loop that we're trying to execute through. So just by adding this simple else statement and having this print statement below here, if I were to now run it this time, so I'm gonna go ahead and run it, we now get 0 through 4, and now the loop has finished running. So that is a use case, just a real basic use case. Let's go ahead and move on to maybe a mini challenge. So for this mini challenge work here, we'll go ahead and put a mini challenge. This is what I would like you to do, and we're going to do this in steps and stages. So we want to create a variable to store a Boolean value called isSuccessful. And we want to initialize that to false. Go ahead and pause the video right now and see if you're able to get that first step done that we need to do. So we're going to do isSuccessful, and we're going to set that to false. All right, that's part one of that mini challenge. We got many more steps to go through. Next, what I want us to do is I want us to create a for loop that iterates through a range, simulating sending message attempts. So think about what we just got done doing with 1 through 5 and it printing something. So instead of printing, let's go ahead and print out attempts. Go ahead and pause the video and see if you can get it to display that. All right, well, hopefully you ended up getting that part as well. So I'm going to do the following. I'm going to do for I in range. And how many do we need? It says 3, right? Through a range of 3. And go ahead and print the message here. And that's really all I want to do for this part right here. So hopefully you ended up getting this. I'm going to go ahead and save it, run it. Sending message attempt 0, 1, 2. If we wanted to fix that, of course, we can add a +1 to this. And that way it will at least read properly. Sending message 1, 2, and 3. All right, perfect. So what I would like us to do next is put an if statement in here, because we can do an if statement, by the way, and we can say if the message is successful, go ahead and break out of the loop. So let's go ahead and put this up here, and let's code this one along together because we haven't introduced the break yet. So we can say something like this. We can say if, and then is successful. We do want to put a break, but before we do the break, we want to print that it is successful. So print message sent successfully. Now, something that we can do here to test this part out, the break part, is let's change this to true and see what happens. We only get, and if I highlight this and run this only, sending message attempt 1, so it attempts to send it. And then because is successful is set to true, it's going to break out of the loop. Notice that we didn't have to go through it over and over and over again, right? So that's pretty cool. I'm going to go ahead and put this back to false to show you that if is successful is false, it's totally going to ignore the block of code from 4 through 26. So let's go ahead and run this one as well. And notice that I still get the sending message attempt 1, 2, and 3. Now this is where our final thing happens. We need to have an else block that will print 3 attempts have been made if it actually went through the entire loop process. Okay, so this is where we're going to think back in our notes. Hey, where did the else statement go? And I threw this if in here to get you thinking and remembering about indentations. Because I can put an else here, but it's tied to this if statement. I don't want it tied to that if statement. I want it tied to the for loop. So I'm going to do an else for the for, and then I'm going to come under of print 3 attempts have been made. So now if I save it, run it, let me go ahead and highlight and run it. It says 3 attempts have been made. Now, here's the thing that I want you to think about is what if I change this to true? What will we see? Will we even see this part here? Let's go ahead and highlight, run it. Sending message attempt 1, message sent successfully. So again, the key to bring up and think about in this else part, this line 27, only gets executed if we've gone through the loop completely. And in this case here, it happens to be, has the loop been ran 3 times? And if it did, then it comes down here. If it did not, we used a break statement, which means we broke out of the loop. We're no longer inside of it. And we get this message here. All right. So it's just going to take a little bit of time to get used to thinking about the loops. Just know in the back of your mind, hey, if I need to break out of it, I can use the keyword break. And if I need to print out a message, or if I need to do any kind of cleanup code, as you would say, it can be handled in here once the loop has finished running. All right. So we'll see you in the next video. All right. I hope you're ready for this video. This one's going to be nested loops. And I know we've seen a lot of videos with loops so far. Hopefully you're not getting sick of them. However, this one being nested loops, it is something that's going to be a little bit confusing at first. Hopefully the video will kind of clear it up along with some of the examples that we're going to have for you below the video for you to complete. But it is something that's worth noting as well as understanding, because if you're utilizing Python for any kind of algorithms, loops are probably going to be in your future. So let's go ahead, take a little bit of a dive into nested loops to show you what we can create with them, as well as you're going to be revisiting this later on once we start talking about lists. All right, so let's go ahead and dig into the code here. This is what I have set up here for us. I have it in the Python folder lessons, and then I have nested loops.py. Now, as far as nested loops, these are loops within a loop, not to get too confusing, right? But loops within a loop. And let's go ahead and do a real quick example of what one looks like. And we're just going to utilize a simple print statement to give us X and Y coordinates. That's what we're kind of looking for here. So with that being said, let's look at the following code. We're going to do for, and then we'll do X. Again, we can choose whatever variable we've been wanting. In the past, we've been doing I, but I think this makes sense for coordinates. And we're going to say in range, and then we're going to supply 5 of these. So in my mind, I'm already thinking, hey, we're going to start off with, and I want to print the coordinates like 0, 0, and then I want to go down the list of 0, 1, 0, 2, 0, 3, and so on. So that's what we're going to do. So we have our X. Now let's go ahead and do a nested for loop. Again, notice that we have some indentations here. Now, I don't like the way that this thing looks, and I'm going to utilize a formatted string here. And we're going to utilize the following to make it look more like math coordinates when we actually print this out. So the idea or the concept here, and I'm going to change this to 3 just to get a little bit of differentiation between the two loops. The idea is that we're going to start off here, and then we're going to get an X value. And obviously it's going to be at the very beginning because we gave it 0 to start off with. And then the next thing that we do here is the Y. The Y is in range of 0 to 3. So when we get down here and through this print statement, at the time that it enters this loop, X is 0. And then we're going to move on to the Y, and the Y is 0. So it's going to print out 0, 0, 0, 1, 0, 2. And I'm going to do something very special here for us once we see that it does print it out. So we got 0, 0, all the way to 4, 2. Okay, so those are the grid coordinates, but let's take a deeper dive into this. And again, don't follow me, just watch the screen here, and you can follow along this with me showing you the little debugger. So I am going to put in a breakpoint here, meaning that I'm going to stop code in the middle of it executing, and we're going to be able to see some of the values and variables that are around, that are localized on this file. So I'm just going to go ahead and click on the run and debug, and you're going to see that mine actually stops here. And again, don't try to follow along with me. I'm just trying to explain things, so you do not need to do this on your own computer. So what I'm trying to get at here is if I draw my attention over here, I see an X value of 0. I have now entered the for loop where X is 0. Right now, I don't see a Y because my program has not entered the Y loop quite yet. So I'm going to hit this button here where I'm going to step over it, and notice that I do have a Y. Let's see what the program does next. All right, I'm still inside the loop that's right here, the inner loop. Notice that we have an outer loop and an inner loop. So I am stuck in this inner loop until it finishes up with its count, right? So here we go. Let's take a look at what's going to go on. So I'm going to go ahead and do this. Notice that our Y value has increased, and we're still inside this loop, and now it's down to 2. Now look where we're going to go. It says, hey, how many times did we do this? We're on our 3rd try. Let's go back to the outer loop and get the new value because we're not done with that outer loop quite yet. Now, again, we're going line by line. It's going on to the next one. It enters this loop. It treats it as if it has entered the loop for the first time on this, right? Let's look at this Y value. It was 2, but now it's back to 0 again. So we're going to go through that entire loop again 3 times, and then we're going to go back to the outer loop and go through it again. So that is where this does get confusing for students to kind of think about and go through. Hopefully this breakdown of our little debugger has kind of helped you think about it. All right, let me go ahead and close down some of this stuff here. All right, let's go ahead and do one of the examples that's below this video here, which happens to be a multiplication table. So we're going to do a mini challenge here. And our mini challenge is create a multiplication table for 1 to 5, utilizing nested loops. So the outer loop, so if we're thinking about this, we want an outer loop to go from 1 to 5, and then the inner loop will go from 1 to 10. All right, let's go ahead and give this one a try. So we're going to do 4, and then we'll just do the multiplication table here. We can do I, and we can see this right here, 1 to 6, that will provide us with the 1 through 5. Remember, this is a start and stop. And then this is our ending here, right? This is the last part of it. And then we have this right here, which will go all the way up from 1 to 10. Remember, this is a start point, and then this is an ending point up to, but not including. That's the way that I always think about this. And then we're just doing a formatted string here with the multiplication. We actually have some math being performed right here to provide us a value. This last part right here, once we're done with this inner part, we want to go ahead and just print a blank line, so that way it makes it look semi-decent. Let's go ahead and save this, and I'm going to highlight and run it, and there we go. We have 1 times 1 equals 1, 10, right? All the way up to 10. So this is a nice little miniature challenge. Again, go ahead and try to re-go through this part here of this inner and outer loops. We have several examples below this video that will help re-age the mind on a little bit of problem-solving skills on how a nested loop could help you. Now, again, we haven't talked about list quite yet. That's going to be very helpful, but you're going to have to wait for that video to come a little later on in your course. All right, so we'll see you in the next video. In this video, we're going to be talking about while loops and why they are important for your programming here. Not only is it going to be important for you to know how this works, but we do have some projects that are going to utilize while loops, so that you definitely want to pay attention to this module. So let's go ahead and get in the code here, and then we'll talk a little bit about when do we want to use these while loops and why are they important, right? So inside here, I have our basic file setup. I have a Python folder. Inside there, I have lessons, and then inside there, I have while-loops.py. All right, so while loops, they are basically a block of code that will be executed until a certain condition is met, until maybe we reach the game-winning point, right? Until player 1 wins. We want to still stay in the game. And that's one of the main reasons why while loops are really great, because it's going to be conditional repetition to execute code, and we don't know how long it's really going to take in order to get there. All right. So that's really why we want to use these while loops. But let's go over an example. So let's go ahead and create a simple example here. We're going to count, just like we did on the very first one when we did loops with you all. We're going to count from 1 to 5. And for that, we're going to create a variable here called count. And we're going to set that equal to 1. Now here's the while loop syntax. It's going to be the following. We're going to say while count is less than or equal to 5, then I want to go ahead and print out the count. Once I get done with the printing of it, I do need to manually increase it to a count plus 1. All right, let's go ahead and take a look to see how that looks. So I'm going to go ahead and run it. And we do, in fact, get the 1 through 5, all right? So something to pay close attention to. This right here is very important. As long as this condition is true, we're going to stay inside of the loop. I want to make sure that you understand that. While we stay in this loop, while this condition here is true, we're going to stay in this loop here and continue and continue and continue. It is possible to get into an infinite loop, but we'll talk about that in a different module. All right, but this is just a real simple example on how we can create a 1 through 5. All right, now, like I said, typically we're not going to do this, but maybe we can think about it in the bigger picture is, hey, let's go ahead and stay in this loop until a player gets to 5 points, and then they win. So again, just think a little bit bigger than what we're trying to do right now with just the small steps. All right, in this next example, I would like to show you how we can utilize a while loop to capture a user's input, and it's going to continually display and be ready for a command to be put in until the user types in the word exit, and that will trigger the program to exit. So let's go ahead and run through it. And again, with programming, everything's about following patterns. So just like we need some sort of variable to capture the user's input to store it in memory, just like this count right here is outside the while loop, we're going to do the exact same thing here. We're going to have this be our user input example. So user input example, and we're going to do something like this, user put, and we're going to set that to an empty string, just like the pattern that we saw up here. The next thing that we're going to do is we're going to say while user input does not equal set. Now, what do we want it to do while it's inside of this loop? Well, we want to prompt the user to answer a question, or we want to prompt the user to have input, but we want to store that into the variable that we created up here. So we'll do something like this. We'll say user input, and then go ahead and type the word exit to quit. And then at the very bottom here, it's just going to mirror what the user has typed in, just to demonstrate that this variable up here that we created on line 15 being updated by this right here, this line right here. So that's what we're going to go with as far as this goes. Now, whenever we're dealing with user input, unfortunately, we can't use this normal play button that we have up here. And that's because this box over here is read only. So the way that we're going to go about this is we're going to right click this and click on Open Integrated Terminal. Now, once you do that, you'll see something that looks just like this down below, and you'll see this little cursor where we can type things in. And again, that's going to be your terminal. If it looks a little busy, feel free to type the word clear. It will clear it out, or CLS for Windows users typically clears that out as well. Now, to get a Python file to run, we want to make sure that first we save the file, and notice that this is saved. Next, we want to go ahead and type in Python, and Mac users will type in Python 3. I believe Windows users will type in Python. And then we're going to go ahead and hit the space bar, and then we want to type out the file name. And once I start typing the word while, and then I hit the tab button, you're going to notice that the file has completed. It auto completes for you. So I'm going to go ahead and hit the enter key on this, and it says type exit to quit, or I can type whatever I want in here. So I can type hello, and it says that you typed out hello, right? Now, if I type the word quit or exit, it finally ends. Quit didn't work, but exit did. So that is our program that we just put in right here. Now, one of the very beginner problems that a lot of new beginner learners out there think about or try to do, I'm going to go ahead and clear this out here. And let me rerun the whole file again. I just hit the up arrow a couple times, and that gave me this, so I didn't have to type it all out again. But what if I type the word exit, all caps, and I hit the enter key? Well, that didn't work. Well, why didn't that work? And if we remember back to strings and comparison, right? Because this is a comparison operator, my line 17 has that not equals, that's a comparison. It's because taking it for lowercase, right? It wants this to be all lowercase. We used uppercase here. Those are not equal. So something that you may want to think about is, how can I get whatever the user types in to equate to this? And a lot of times beginners out there will do something like, and then user input not equals, and I'm going to go ahead and maximize this here, not equals. Well, that's perfect. That does work. But what happens if, and again, I'm going to exit out of here, clear, and then save it and run it again, just to demonstrate a few things here. So if I do sit, it now works. But what if I did the following? What if I did E, X, and then an I, and then a T, right? So now we're trying to dummy proof this, so no matter what they typed in, this comparison should work. And the way to go about this is to think to yourself, all right, how can I make whatever they typed in, how can I convert that to be all lowercase? Do we have something out there that can convert whatever the person typed in all to lowercase? And so we do, and we have something here called dot lower, right? And so if we use the dot lower, now this is converting what we typed in all to lowercase, and our comparison only has to match off of this over here. Now, of course, we could use upper here, but then we'd have to change this one to all uppercase. So it does need to match, but typically what you'll see is let's just go ahead and convert everything down to a lowercase in order to get this to work. So again, I'm going to clear out of this, and then I'm going to go ahead and run it in the terminal. And so now I can do EXIT, where the EX is all capitalized, and hit the Enter key, and now I have successfully exited the program. So again, this little tip is going to be very valuable to you to remember for challenges that you might have. And just know that, hey, in order for me to get a good comparison based upon what the user has typed in, then this would be what you were wanting to use, is make everything all lowercase, comparing it to an all lowercase hard-coded string on the right. All right, so that is while loops. Again, we're going to do a little more practice with some challenges and stuff. There's more examples below this video for you to try out, test out. But I just wanted to demonstrate to you in this video what a while loop is, and then maybe a potential use case for it here. All right, we'll see you in the next video. In this lesson, we're going to be talking about functions, and functions are going to be a day in life of every single time that you program. You're going to have to involve some functions. And one of the things that I see a lot of students fail to do or recognize is that when we create these functions, that they're actually not being used until you actually call them. And we're going to show you several examples in this video on having functions, calling the functions, and hopefully you're going to start seeing the pattern of, hey, I totally understand this part here about functions. So without further ado, let's go ahead and get inside of the code here. And I'm in the Python folder, lessons, and then I'm in the functions.py as far as the file goes. I'm going to go ahead and collapse that and kind of talk a little bit about these notes here. But just to reinforce this idea here, functions, they are a way to kind of group code together. We are going to give it a name, and then in order for the function to be ran, meaning that the lines of code inside that function are not actually ran until that function is called. And a lot of times we're going to be coming up with a function name that talks about what actually happens inside of the little grouping of code. And just like before, whenever we are talking about loops and if blocks, everything in Python is all about indentation. So we're going to reinforce that idea, that concept of whatever's indented inside of the function is the code that will get executed when the function is called. So let's go ahead and write out our very first simple function. So we're defining a simple function here, and it starts off with the keyword of def. We're defining a function. So we're going to do def, and then we're going to hit the space bar, and then we're going to provide it with some sort of name. This is going to be the function name. And so we'll say something like greet, and then we must have left and right parentheses, and we're going to put a colon on there. Now, just like I told you before, anytime we are wanting lines of code to only be executed within this function, we must indent it, as we see right here. Now, if we were to go ahead and save this and run this, we're not going to see anything. And again, this is that concept that I was telling you, that whenever I'm trying to teach this for students, they write out the code just like this and they try to run it. They're like, hey, I put the print statement here, it's not working. Well, it is working. It's just you created a function. Now it's time to call the function. So let's go ahead and call the function here. So we'll put the little note here. This is calling the function. And you call it by followed by the left and right parentheses. So I'm going to go ahead and save that and run it. And now we get hello. It's printed to our console. Now, important thing that I want you to get out of what we just did is that you can write a function all day, but the code inside here is not going to run unless you call it up. Very similar to notifying a friend. You may want to say hello to them, but you need to call them first on their phone for them to let them know, hey, I'm getting ready to use you. Now, again, if I needed to call the function again, I can do greet, let these again, save it, and then run it. And we just executed this function twice, which is why we see it in our console twice. Now, something interesting with functions is that they are, well, what does that kind of look like? Now, arguments are values that can be given to a function in order to provide some data crunching or data utilized. In this example here, we're going to do functions with the arguments or with parameters. And what we're going to do here is we're going to go ahead and create one, and we're going to call this one user. And inside the parentheses this time, I'm actually going to type out the word name. Okay? And just like before, we're going to put our colon in there, and then we're going to print, and again, we're going to put that F there to allow us to call out a formatted string that's coming in. Now, the way that I always look at parameters or arguments is, hey, this is a placeholder value. It's almost like an envelope, and this function has an envelope, and I'm going to stuff somebody's name in this envelope here, and I'm going to reference it somewhere in the code. So what do I mean? How do we call it? By putting something inside of the envelope. So we're going to say calling a function with an argument, and we're going to do greet user. And notice that inside of our envelope, inside of our parentheses here, we're putting the word Alice. So now if I go ahead and save this, and I'm going to highlight this and run it, we now see hello Alice. We don't see hello name, and that's because we told our program, hey, I know you have an envelope. In here, I'm going to put the word Alice inside your envelope, and I'm calling it name. It's just a variable, right? It's a value placeholder that I can reference later on. You are able to have multiple parameters or multiple arguments inside of your functions that you define. And let's look at a result of this, or an example of this. So we're going to create a function that takes two arguments and returns the sum of those two arguments. And we're going to call this one add. So we're going to do f_add. And usually you can add in generics like AB, just like what it's suggesting here, but I'm going to put in here number 1 and then number 2. Now I want to add a little bit of clarity for us here. And if we were to simply do something like this, we can say result equals number 1 plus number 2. And then we can come down here and we can return a result. Now that's something that we haven't talked about yet, is that functions can return things. So we'll put this in our notes up here. Functions can return a value using the keyword of return. Return keyword is followed by the value, or meaning like the data that you would like that function to return. So in this example here, we're going to return the result. And so that means down here, we can do a call the function to print the result. We can do the following. We can say print and then add 2, 3. And if we save this and run it, we get 5. And again, this function allows us to put in anything that we'd want here, like numbers, right? To be able to be added together. It's the way that this works is number 1, there's that envelope. 2 is going inside of that first envelope. 3 is going inside of that second envelope, and we are labeling it right here. This is number 1, number 2. So that way we can later reference what we are shoving in that envelope and utilize it here and here. So hopefully that makes sense there. Let's see what else we have to do here. Let's go ahead and do a little bit of a challenge one here for you. Let's go ahead and create a function that will take 2 numbers, 2 arguments, and return the result of multiplying those 2 arguments. Let me go ahead and scroll up. Go ahead and pause the video. We're going to call this one multiply, and see if you can follow the same pattern that we did above, but this time we're going to be doing multiplication. And again, it's totally okay to reutilize these parameters that we saw up here, number 1, number 2, if you want, because that's what I'm going to be doing. because it doesn't affect anything outside of that function. We can reutilize those names. Right, so go ahead and pause the video and see what you get. All right, well, hopefully you ended up getting something that looks like this. We're going to define our function, multiply. We're going to do number 1 and number 2. We're going to do the exact same thing that we did before. We're going to do result equals number 1 times number 2, and then we're going to return the result. Let's go ahead and call the multiplication one. And for that, we're going to do multiply 2 times 3. So let's go ahead and highlight this and run it. We get 6. All right, so here is one of our final challenges that we have here while we're going through this video of learning a little bit about functions. So what I want us to do is I want us to create a function that will convert Celsius to Fahrenheit. It should return the Fahrenheit number. So I'm going to stub out some code that we should follow along with and try to do. So we're going to do challenge, create a function that will take in one argument and return the Fahrenheit of that argument. There we go. Let me go ahead and spell Fahrenheit properly. So it's going to take in the Celsius, and we need to convert the Celsius to Fahrenheit. Here is the notes that I have for this to also include a formula where we want to convert the Celsius to Fahrenheit. The formula that we need to use is the Celsius. You multiply that by 9/5, and then you add 32 to the end of that in order to get the Fahrenheit. Parameters, what we should probably use on there is going to be Celsius, and then it's going to return the Fahrenheit. So go ahead and pause the video, see if you can still follow the pattern that we put up here. Let's give good names for our arguments and variables, because that's what we want to keep instilling in you as you're going through this. So pause the video, see if you're able to get it. All right, hopefully you ended up getting this. If not, we're going to go through this. So we're first going to write our function, right? We want Celsius to Fahrenheit. And then as far as our parameter, our argument, we're going to make that Celsius. And then we need to create a variable. So instead of result, like we did before, let's use something that's really nice and clear, concise, and that's going to be Fahrenheit. And then we're just going to plug in our formula that we have right there. And then we want to return the result, right? We created a variable here. We are utilizing the parameter that's going to be coming in, and then we're just doing some simple math right here, and then we're just returning what that value is. Now, I told you before that in functions, right, they can return a value. Many times as you're programming it, you're not going to be printing things from it. You're typically going to be storing whatever that function gave you into a variable. And so what I want to show you here on this is we can say, for example, let temp1 equal, and then we're going to do Celsius to Fahrenheit, right? So we all agree that 0 degrees Celsius, right, that's freezing, would equate to 32. So let's test out our function here. So we're also going to need to print temp1, and let's get rid of the let here. So we're going to do temp1 equals, and then Celsius to Fahrenheit. We threw in the 0 that we see right here. So it's going to run through the calculations. 0 times 9/5, right? Anything times 0 is going to be 0, and then we added 32. So we should get 32. Let's go ahead and highlight it and run it. And there we go. We get 32. Let's try another one. We'll do temp2, and this time we'll throw in 100. We'll go ahead and save that, run it once we print it, and we should get 212. Let's go ahead and run it, and there we go. Now we get 212. Perfect. So we created something that's reusable. We didn't need to put in anything where just as far as a little formula for each one of these. We are reusing the same formula over and over in order to make a few calculations for us. So as we go further along in the course, of course, we're going to have some more challenges that are going to be involving functions. You're going to have projects that are going to be involving functions. So that's what we wanted you to get out of this lesson is functions are going to be pieces of code that will only get used if you decide to call them, and that they are typically pieces of code blocks that are reusable. They're only code that you want executed whenever you call them, and they are reusable. So hopefully this lesson made sense, and we have challenges that will help you further learn about functions in Python. See you in the next video. All right, in this video we're going to be talking about default values inside of functions, because sometimes you may call a function, but you may not utilize all the parameters that are in there, and so you may want to provide a simple default value. Now, with this being said, I just wanted to introduce this to you, not necessarily that you're going to always be doing this, but just know that it is out there and available for you to use if you need it. And there are some rules associated with this, but we're going to talk about that here. Let's go ahead and go into the code, and inside of our file folder setup, we are in Python lessons, and then I have a simple file here called function default value.py. I also have some notes up here that we're going to go over, but with that being said, functions have a default value for their parameter. And this means that if the function is called without that value or without that parameter, the default value will be used. If the function does happen to get called with that parameter, that argument, then it's going to use what the caller is going to be applying. So there are some rules associated with this. We'll cover that here once we discuss our simple function. So we have a very simple function here where we're going to supply a default value, meaning that if we call this function, let's go ahead and create the function first. We'll do def and then greet, and then we're going to do a name, and then we'll just do a simple message equals hello with the following print statement. Now this is the part that's new, is the equal sign and then the hello. That is the new part of what we're talking about, because if we didn't have the equal sign, it's the same as this one right here, which is just an argument and the function requires it. So let's go ahead and do the following. We can say greet, and then we'll say John. So notice that we did not supply a message with this, and we get hello John. So the message gets applied with the default value. Now the next part here is let's do a greet with a John and a good morning for the message. So now we actually supplied a message, and then we're going to go ahead and hit the run button, and now we get good morning John. Now there are rules associated with this, and that's what I have marked out right up here, that only put the optional parameters at the end of your parameter list. That means that I cannot do the following. I cannot say, you know what, I want the first argument to be the message, and then I want the next one to be the name, but I want that first one to be optional. Notice that we're getting these red squigglies, and that is because we need to shove all of the optional ones over to the far right. So the mandatory ones go on the left, the optional ones are always going to be on the right. You can't skip in between. That's another downside of the default value if you picture it being a downside. So again, if you're going to do default values, you want to put them after your final one that is required. So hopefully this little lesson helps you out. Like I said, I just wanted to give you exposure to this. Not necessarily that you're going to use this all the time, but just be aware that it is out there, that you are able to add default values to your functions inside of Python. See you in the next video. All right, in this video, we're going to be talking about functional scope. And usually when I bring this up to students, they always think of the mouthwash scope. That's not the case for this video. But what we're talking about is if we're defining variables inside of a function, do we have access to them outside of the function? Or if we create global variables, do we have access to them in the functional scope? I know we don't know what scope is, but let's go ahead and find out. So let's go into our code here. And with that being said, I do have the file folder set up as Python. We're inside the lessons folder. And inside the lessons, we have function-scope.py. That's where we're going to be living for this project here. And so basically function scope, it's where we are creating a variable inside of a function, and it's only accessible inside of that function. We're not able to access it outside of the function, which makes it kind of interesting, but also a blessing as well, which means that if we create multiple functions that utilize the same variable name, we don't have to worry about there being any kind of conflict. So let's go ahead and do a real quick example here. And in this example, I'm just going to create a really simple function here called sum, and it's going to take two parameters or two arguments in order to add them together. So let's go ahead and do that here. So we're just going to define the function, And again, like I said, it takes two numbers. We have a new variable that we created here called total, and it equals num1 plus num2. Now let's go ahead and add a secondary function called the difference. And the only thing that we're going to change in here is going to be the plus and the minus, and then obviously the name of the function changes also. Now, what's interesting to note here is that I am utilizing the same variable name, right? Total. Using it here. I'm also using it here. So usually when I'm talking about this in front of a live class, I'll do something like this. I'll say print the sum of 5 and 3, and then it's going to give us the total, right? And then what if I did print difference? And then we'll do 10 and 7. So a lot of times students will say, oh, total is going to be 5 plus 3, that's 8. So the first one gives me 8, right? So let's go ahead and save that and run it. Cool. And then the next time they run through this and they're like, okay, total's 8 now, but like, what is it going to be when we do the difference? So remember that when we're talking about scope and we're talking about creating these variables inside of a function, they are looking for those variables on the inside of the function first. Meaning that, hey, we're looking at this right here inside of the function for the word total. So this right here is looking for the word total. It's looking for this num1 here. It's going for here. It's not looking outside. That's what I'm trying to through in this lesson here. So let's go ahead and run this and save it. We do get 8, we do get 3. So it is utilizing the numbers that we supplied, and it doesn't get any confusion whatsoever with the numbers that we've used before. Again, we have reused variables inside here, but because of scope, this function right here is only looking inside here for these variables to begin with. And we're going to show you an example of creating a global variable and being able to reference it inside of a function as well. So let's go ahead and demonstrate that. All right, so let's talk about the global scope. And this is just a new little term here for us to understand and retain here, because functional scope, we're dealing with functions. Global scope, we're dealing with things that are outside of the functions. And what do we mean by global variables? Well, what if I were to do something like this? I'll do total equals 15. So let's have a function here, and I'm going to reuse the same functions. And in order for this to work for us, we're definitely going to have to highlight the code and run it. But I'm going to do another function here. We'll do a sum, num1, num2. And this time, I want to go ahead and do the print, and then we'll do 5 and 3. And then I also want to print the total here. So this is going to get a little bit interesting, and then we're going to show you a little bit of a workaround on how to deal with altering global variables and things of that nature. So again, I'm going to have to highlight this code in order to get this to work, because we already have a function name up above called sum. But if we highlight the code and hit the run button, notice that we get total equals 8 inside of the function, and then we get the total on the outside of the function. It's referencing the global one. Now, we can't simply alter the code as of this and say, you know what, let's just go ahead and do total equals total plus num1 plus num2 and see what we get here. Let's go ahead and highlight this and run it. We're going to get an error. And that's because it's saying, hey, we don't know what this total is. It's nowhere defined inside of this function here. So one of the workarounds, and this is the one that's kind of frowned upon using, is the following. What if we were to type the word global and then put the word total in here? And so now we're telling this function, hey, you know what? We need to reference the global variable first, and then let's go ahead and utilize this function. And so now we get 23 for the total that's getting calculated inside of the function. And notice that when we print the total now, we do get the total no longer being 15. It is now 23. So they're now equal. We just told this function, hey, use that global total and alter the total. Now, this may be bad practice. how are some ways that we can get around this? So let's go ahead and try another example here of a way to alter a global variable, but still have the function alter it. So let's look at that without using that keyword global. So we have this, and let's go ahead and do the following. We're going to create, it's almost like a bowling application here where we need to update the score. So it's going to take the current score, and then we're going to apply points to it. So this time we're supplying it with the information. So let's look at this. We're first going to create a global variable called current score. And with the current score being 50, we are now calling this function here update score. It's going to come in here, and we're supplying it with the current score. And then we're also supplying it with how many points do we want added to the score. So then we come in here, the score is 50, right? 50 plus 10, it equates to 60, and it returns the score. And notice that we're doing this properly by updating a global variable here based upon a function. Pretty interesting, right? And this would be a good solution as an alternative than calling out the global inside of the function. So for best practices here, we're going to be utilizing this. All right, let's go ahead and save, run this, and you'll see that we do in fact get 60 for that updated score. All right, now scope is going to be something that's always going to be around you. It's always going to be thought of whenever you're doing some of these projects and when you're coding, right? So it's just be really vigilant in your coding practices to know, hey, do I need this to be a global variable? Okay, well, does the function need to access that global variable?
So I really hope you enjoyed our lessons on Python fundamentals. We have challenges on our webpage if you wanted to take a look at that. Thank you again for watching this, and stay on the lookout for more Python lessons on YouTube as well as our website.